house rules. Okay, cool. I think we have all gotten the notification of the meeting is now live stream. So perfect. Okay, yes. So a few house rules. I really request that we all pay attention, switch our phones off as we go through the sessions, and pay attention to what our facilitators are doing. We engage with our facilitators. I request that our facilitators will give their own instructions of how they would like to go about their sessions, if they want to be interrupted for questions, or if you will share your questions in the Q&A and then they can attend to them later. I encourage participants to ask questions in the Q&A rather than the chat, so that we do not lose any of the questions. And then really enjoy the learning, engage, even amongst yourself, amongst other facilitators, or rather participants, not only facilitators. And then, as you have seen on the schedule, we did sort of a different kind of program from what we usually do for data science, for a typical summer school, Data Science Africa summer school. We have a networking session at the end of every day. So the teaching happens between 8:30 and 1 to 1:30 sometimes, some of the days. And then at the end, we have the whole afternoon open for learners to engage with facilitators. We have requested facilitators to drop in or stay for longer where it's possible, but then they can be able to attend to some of your questions, because some of the courses will have they will have assignments. So if you have some of the questions, to ask that. And then, of course, as you have also seen in your emails, we have a hackathon that we have on Zindi that is going to be launched. I think our time is going to be noon CAT, is going to be live. So we hope that during the afternoon session is when you will get to innovate your solutions for the challenge that was put up. And then these results are going to be compiled and announced on Friday, which is going to be the last day of the workshop then. Amy from Zindi is going to be with us later on in the session to explain how to go about the hackathon. So if you have been having any questions about how you're going to participate, how you're going, if Zindi, if the Zindi platform is new to you, have them ready for Amy, who's going to be with us later in the day, as you can see in the schedule. So check on the schedule. I hope that all of you know the website link, but just in case you do not know, maybe Ila, Johanna, you can help me share the schedule link in the chat for everyone to see. So keep checking there to see what schedules are, or rather what topics are coming up, who's facilitating them. And then also, I actually wanted to share something. I don't know if I can share my screen. I want us to tweet about the event as well. So let me just share some of the Twitter handles that you can use. So I'm just going to share the poster for this event. Chair, I request that you help me keep track of time. I don't know if I've already gone out of the time limit of opening remarks. I might be taking long. All right, so I think I got you can all see the poster that I have on the screen. You can just type yes. Okay, so but if you can, these are going to be our Twitter handles. So Women and Data in Africa, DSA 2021, then DSA at SPU. So if you want to tweet and tag, those are some of the handles that you can use. Feel free to be creative and add more. And then this also you can find on the website. But yeah, to tag in, our hosts, our sponsors, and the different partners that are of this event. So without further ado, I want to get into the session already. Let me stop sharing my screen. And yes, so I want to hand over to our first facilitators of the day. So the topic being Python basics and data analytics. Dina Machovu and Nima Duma, I think you're already in the session. Please go ahead and set up your presentation. I think you should be able to share your screen already. Is that the case, Dina? Perfect. So thank you. I will allow you go ahead and introduce yourselves and get started. Thank you very much, everyone.
Yeah. Hello, everyone. And thank you so much for inviting me to the DSA 2021 Women and Data in Africa. I hope you can all hear me. Yeah. Yeah. So we'll take you through the data analytics in Python. And in this module today, the presenters will be myself, Dina Machuve, and Neema Mduma. We both work at the Nelson Mandela African Institution of Science and Technology in Arusha, Tanzania, where I'm a senior lecturer and Neema is a lecturer in the School of Computational and Communication Sciences and Engineering. The agenda for today will be on data analytics, where we'll take you through the basics and fundamentals of the data analytics pipeline and the fundamental libraries of Python that are used in data analytics. And then we'll dive into a case study on financial inclusion in Africa and see how we can go through the different blocks of the data analytics pipeline. And we'll finish with a coding example on data analytics for that case study on financial inclusion in Africa. So basically, everyone will ask on what basically is data analytics. In a nutshell, it really means it's the process of exploring and analyzing large data sets to make predictions and data-driven decision-making. When we talk about predictions, that is modeling using machine learning. And you use data-driven decisions in order to make informed decisions using data. So we'll basically go through the different techniques that enable this process to take place. So there's normally a difference between data science and data analytics, although they do overlap. Data science actually means the algorithms and the scientific methods that are used to extract knowledge and insights from structured and unstructured data. Whereas data analytics means you are using software and specialized techniques to inspect data set and make conclusion, to make inferences. And its focus is really specific. You have a specific goal to achieve. For instance, you are looking onto the marketing or financial data, and you want to answer a specific question. Whereas the scope of data science is bigger. But I said earlier that they do overlap in that data science uses machine learning and AI, whereas data analytics mainly doesn't reach to do the machine learning work. You actually prepare data, finding insights from the data, and you're able to answer specific questions. Both fields, data analytics and data science, they use statistics, also visualization. You also have to do some data cleaning and mining. Whereas data analytics, you end up reporting the findings for the specific question or the goal that you want to achieve. Now, when we go on to the data analytics pipeline, we see these 5 key stages, but really data analytics focuses on these first 3, where you have a research question that you want to answer using data. So you have to do some data cleaning and validation and exploratory data analysis to understand the data. And actually, as a data scientist or data analyst, you spend almost 80% of your time here preparing this data set for analysis. And after all this is done, that's when you go on to modeling, where machine learning takes place at this modeling phase. That's where you actually start doing machine learning. So you can say that data analytics is the important stage. All these 3 stages are important for doing preparing the data for machine learning. So when you look onto the first block, which focuses on the research question, it's actually what you want your model to answer, what question. And these are some of sample research question where you have data, diagnostics data on malaria, and you want to answer the question whether the patient has malaria or not. And here, if you have sensor data collected using IoT, can you respond to this question on monitoring illegal deforestation by detecting chainsaw noises in audio streamed from rainforest? So you can see here, your data is audio streamed data. So how can you use that data to answer this question on illegal deforestation detection? And you have data on chickens. You have the chicken fecal samples, that image data. Can you determine whether the chicken has disease or not, which is, in this case, is the Newcastle disease? So these are sample research questions that you want to answer using data. Now, actually, we can say it's a chicken and egg situation, because at times you go on to look onto your data, you try to validate and clean it and do exploratory data analysis, but actually it forces you to refine your research question. So it's actually an iterative process going through this pipeline. It's not one-way traffic. When you look onto your data, after you do exploration of the data, you might develop your model. You can go ahead to develop your model, or at times you are forced to refine your research question, or even at times add more data to answer the question properly. Now, when we look onto the second block, which is on data validation and cleaning, we really have to ask ourselves, why do we need to clean or validate this data? We already have the data, we have our research question, we can go straight to use the data analytics techniques to respond to the question we have at hand. But it's really a very crucial step. And I said earlier that it takes even almost up to 80% of the time of a data scientist to do data cleaning and validate the data, because the data comes from multiple sources and is created by humans. And at times, based on the question you want to answer, you might need to even transform the data. And also you have to make sure that the data is free from human bias and doesn't have errors. And when doing data cleaning, we really focus on identifying issues on the data and confirming whether you have a qualitative understanding of the data. And normally when cleaning the data, you normally come across these 4 cases where you might have missing data, and you have to find out whether the data is missing systematically or random. You also have to be sure of the data type of the variables you have on the data. And also at times you have to validate whether, if it's a time, the data is timestamped, whether the data is on the correct time range. And also, if you are working on a data range, you have to make sure that all the values in the expected range. Yeah. So when we focus on the missing data, you normally have to, there are normally these common cases, whether the data is missing at random or systematically. Most of the time, very few data sets that don't have missing data. That means they were really properly pre-processed. But normally you have to ask yourself whether the data is missing completely at random, which means there's no pattern in the missing data. And whether if the data is missing at random, that means there is a pattern in your missing data, but not in your variables of interest. And when the data is missing and not at random, that means that there is a pattern in the missing data, but it really affects your primary variables. So you have to find a way of dealing with it. Let's look at this example. That you have survey data from a random sample of high school students in Kenya. And some students did not participate in the survey. So you have to ask yourself, some students were sick the day of the survey, okay, during the day of the survey. If the data is missing at random, we can use the rest of the non-missing data without worrying about bias. And then we have another case where the students declined to participate since the survey asks about grade. If this data is missing in a non-random survey, is missing in a systematic way, your non-missing data may be biased. So in these two cases, we have to make a decision which data set to go on with our work. Is it this first case where the students were sick at the day of the survey, so it means we don't have to worry that the data was biased? But this second case, the data was biased because some students didn't participate, and we are sure, we are very well informed that the reason they didn't take part is because the survey asked about grades. So there's a probability of having this bias if we continue with this case. So actually in this scenario, the right data set to continue with our work is actually this one here. In the case where this data is missing at random, and we don't have to worry about bias because some of the students were sick. So these are some of the questions that you really have to ask yourself before you continue now doing the analytics and eventually modeling. You from the initial stage of doing the data cleaning and dealing with the missing data, you have to take into account all these case studies, since how the data was collected and the different scenarios which represent the data set. So what decision now do you have to take when you come across missing data? Sometimes you can decide to drop the missing observations, or you populate the missing values with an average of available data, and then or you can really impute the data. So those are some of the decisions that you can do when you have missing data. But all in all, it heavily depends on your research question and the data that you have collected. Because at times when you think about dropping data, the missing observations, while you have very few when we have very few observations, might not be the case. So this decision heavily depends on your research questions and the data. And normally, these are some of the techniques that you normally have when you normally use when you have to make a decision on how to deal with missing data. You can either use the average of the non-missing values or make an educated guess. For instance, as a data scientist or data analyst, in experts, they can help you to make an educated guess for the missing value. For instance, if the participants responds with all fours, you can assume that the missing value is a 4. Or if you you have you are working with the person who collected the data, and you talk about the missing value. They can really recall of what that case means and be able to help you make an educated guess. Or you can use you can substitute the median values, whereas here you could replace the missing values with an average. Those are some of the decisions that you can use to handle missing data. Now, when we move to the next block on doing data analytics, which is exploratory analysis, the main goal is to better understand your data, and and also understand what are the limitations of the data, being able to discover the features that are important. It is a very crucial step in any data analysis or data science work, exploratory data analysis. And at this stage, when you do when you reach this stage, that means you have clean data. And normally we have these techniques which involve visualization. You can use histograms, scatter plots, correlation, box plots, summary statistics to explore your data, to be able to identify the patterns and better understand the data before you start modeling. So when do we use histograms, and what do histograms tell us? Histograms tell us about the distribution of a feature. So you have, like in this case here, you have a feature of heights of 30 people. And another thing to note, that a histogram deals with continuous variables, numeric values. Here we have plotted a histogram representing the feature of heights of 30 people. And here you can make you can determine that most of the people have the height between 149 and 159 centimeters tall. So the main thing about histograms, that means you deal with a continuous feature, continuous variable, numeric variable. Whereas scatter plots, they also provide insight, but it's a relationship between two features. Recall, for histogram, we only had one variable, which was height. But here, when dealing with scatter plots, you are looking onto the relationship between two features. Like here, we have the amount funded and the amount requested, and both are continuous values. Like here, when we do a scatter plot on this amount funded and the amount requested, this is a data set on the loan amount. So we can see here there's a positive relationship. When the amount funded increases, the amount requested also increases. So we can conclude that there's a positive relationship between the amount funded and the amount actually requested. From the scatter plot, you can find what we can call another feature, which we call correlation, which shows the strength of a relationship between two variables. At times there's no relationship, or there's a perfect positive correlation when we say the value is 1. It ranges from -1 to 1. When there is a very strong relationship, this is how it is aligned. It's aligned towards the right. And it decreases when the correlation decreases, and when the value of correlation is 0, that means there's no relationship between the two variables. And at times this relationship can be negative. Like here, it's low negative correlation, and when it reaches -1, it's a perfect negative correlation. But one thing to note when using correlation is that correlation does not equal causation. Okay, what does that mean? Let's look at this example where you have data of value X, that means the horizontal axis is the amount of fund spent on advertising. And on Y, we have the sales value. based on this graph here, you can say there's a positive correlation between the amount, the budget spent on advertising and the sales. But again, you can here, once you see the positive correlation, you can say, okay, I found from this data that the budget allocated on advertising caused an increase in sales. But that might not be the case. The opposite could be true, that actually an increase in sales caused an increase in amount spent on advertising. So that's why we say correlation between X and Y does not mean X causes Y. It could mean Y causes X. That's the meaning of this statement, that correlation does not equal causation. So when you're using this measure when doing exploratory data analysis, you should be careful to have it right. And another technique we use in EDA, exploratory data analysis, is doing summary statistics, which actually describe median, mean, frequency. Again, these are for the new continuous variables. So it's normally important to get a feeling of what is the average, what is the range, what is the mode, and what is the middle value and of the continuous values on your data. And we also have this other technique of doing expression data analysis, which is the box plot. Actually, the box plots are a visualization of some measures of the summary statistics. Here from the box plot, you have the gender, which presents actor and actress, representing the age. And each line here within the box has a meaning. The minimum is represented by this dot here. So here you can tell the actor, which is the male, you can say that their minimum age on this data is around 31. And for the actress, which is the female, is around early 20s. And we also have the first quartile. We also have the median, which is like what is the average age. Here you can determine visually the average age. And here, another important thing, it also indicates the outliers. These values are not within the data set, they're outliers. So you can make a decision even whether to drop them or not to consider them when doing modeling. So you really have a good understanding of your data set before you actually embark on doing machine learning. And here we're going to use Python. And it's a great motivation of using Python when doing data analytics due to this wide range of libraries. And all of these are open source and powerful. And you can do a lot with them. They have the SciPy, NumPy, Pandas, Matplotlib for visualization, Seaborn, and they're very important libraries using Python because you can, they're like the NumPy is useful for linear algebra, and also numeric is powerful for handling numerical computation. And Pandas deals with manipulation of tabular data. And when we talk about missing data, how to handle them, you can perform all that using the Pandas library. And the Matplotlib, as well as the Seaborn libraries, there's Python data visualization libraries, which really show very high level, attractive and informative statistical graphics. We also have the SciPy for scientific computing. You can do integration, interpolation, and even image processing work using these libraries. Scikit-learn, which actually is used for machine learning, to build models with a regression, classification, and clustering models. All these libraries are open source and very powerful when doing data analytics using Python. Now, how do we now apply those techniques in solving this real case study on financial inclusion in Africa? This example is actually, you can find it on the link here. It was a Zindi competition, and you can actually try it on your own on when it was a challenge, saying that we have financial inclusion being a main obstacle for economic and human development in Africa. And the data set was collected across 4 East African countries, where we only have only 14% of adults with actually a bank account. Now they want us to use machine learning to determine which individuals are most likely to have or use a bank account from that data set that was given. So this is really the research question. Now we have to do the data validation and cleaning, where we have to load the data set using the Python libraries we discussed earlier, pandas, and we have to check on what is the data set size, data type, check whether there are any missing variables, and if there are, you clean the data. Look onto the target variable, where it's a person having a bank account, yes, which is represented by 1, and no as 0. So it is a pipeline, it is a process. And when doing exploratory data analysis for this case, we look onto the different features. We look onto the target variable, whether a person has a bank account or not. We look onto the summary statistics of the data set. What is the mean? What is the maximum value with the minimum value of all the numeric features of this data set? What is the gender distribution of the individuals in the different countries who responded to the questionnaire? So you have to do this exploratory data analysis before you make a decision on what model to run. What is the data type? Okay, where are these individuals located? Are they in the rural or urban areas? Do they have access to the cell phones? These are some of the variables that are on this data set. And then we do what we call feature engineering, where if the questions were answered by yes or no, we have to encode them to be numeric values. So we will take you through a coding example for financial inclusion in Africa, where the code walkthrough will give you hands-on NumPy, pandas, those Python libraries, Matplotlib and Seaborn. And we have also a notebook where we'll get some more insights on financial inclusion and also visualizing the results. We have included the link to the Jupyter notebooks on GitHub, and also the slides are also equally available, and you can look onto further on pandas and SciPy lecture notes as well online. We've included the links. And I would really like to thank you for being with us. And my colleague, Nema, will take you through the pandas tutorial. We'll stop here for Nema to walk you through the pandas library, and then I will continue with the exploratory data analysis. Thank you. Yeah.
Okay, thank you very much, Dr. Dina, for the very nice introduction. I'm Neema Mduma, as I've been introduced by Dr. Machuve. So I will take you through pandas for data analysis in order to see how we can use pandas in order to do to explore our data set and do different kind of the manipulation. So Panda is a Python package or one of the library which it has been used for data analysis. And this library, it exposes data structures in 2 forms, which can either be in data frames or in form of series. So when we talk about the data frames, it means it's store tabular data, which consists of rows and columns. And for the case of series, these are similar to Python built-in list or set of data types. And in this notebook, we are going to explore the data structures that Panda provides and learn how to interact with them. So the first stage here, before you do anything, we need to import pandas. And as you can see in this part, in this cell, we import pandas as PD, and then we are going to run this cell in order to be sure that we import this library. So the other stage is to load our data set. And for this part, we are going to use Titanic dataset. This is dataset which is freely publicly available in Kaggle. It is in the category of machine learning for disaster. So the dataset consists of samples which include details of the people who survived and not survived in the Titanic. So you can see here, we write PD. This is just the name which I have just decided to use for you. So for your case, you can change and write anything here. Maybe you can write data or any kind of name which you want. And you assign that name to pd.read.csv and the name of the file, the name of the data set. So for our case, our data is called Titanic and it is in the form of CSV. That's why I write titanic.csv. I'm going to run this cell. Okay. Then after that, I just want to explore my data set in order to know that maybe how many rows are there. And if you just want to explore the first 5 rows of your data set, you write df.head, then open the bracket and close. I wrote here df because this is the name which I have assigned here, so make a note. In case you change df here to be data, it means at this part here, you're supposed to write data.head. So after loading that part, it shows me the first rows of my data set. And I've also been able to see the columns which are in this data set, but when we proceed, I will also show you how you can explore specific columns using its own code. So what if I don't want only 5 first rows? Maybe I just want to explore the first 10 rows of my data set. So the code is the same, df.head, but make sure that in the brackets, you indicate the number of rows which you want to explore. So in this case, I just write df.head and then in the bracket, I just put on 10. It means I'll be able to explore the first 10 rows of my data set. So you can see at this part, I've been able to see the first 10 rows of my data set. Okay, so what if I just want to see the last rows of the data set? So the last rows of the data set can be explored by using tail. So just write df.tail and then open the bracket and close it, and then you'll be able to see the last rows of your data set. The same, if you just want. Hello.
Sorry, yes, sorry to interrupt you. I was thinking if we could take like 5 minutes to first aid the participants to like load the notebook so that they are moving along as you're showing the example.
Okay.
Yes.
Okay.
Dina shared the link, but it wasn't working for me. So I don't know.
I'm checking it. I will be back shortly. Yeah, I'm checking it. Yeah.
Okay, cool. So in that case, then, I mean, maybe Nima, you could be going through the things that participants need to have installed for the notebook to run if they need to, or if they can just follow online. Just to give that bit of an introduction, how to have their notebooks also running on their computers so they are able to go along as you show the example. Thanks.
Okay. So I think after Dr. Dina solved that issue, everyone will have the notebook, and then if your notebook is offline and you just put it maybe on your desktop, what you can do is you can search in your computer. So for me, I can just search here, Jupyter. And then it will open the Jupyter. And then if your notebook is on the desktop, for my case, it is on the desktop, you'll go to the desktop, and then you can go to Data Science Summer School for my case. And then inside you can go to Pandas for data analysis. This is the notebook which we are currently working on. And then it will take us here.
And also how to access the data set. Someone is asking in the chat.
We have shared the data set.
Yeah, the data set is within a folder on the link that I shared earlier. I'm just changing the rights on the repository. I just discovered that it's when working on preparing it, we set it as private. We are setting it public shortly. Yeah. So you can run this notebook either locally, and if you don't want to go through the installations of Jupyter on your computer, you can use Google Colab. It's quite direct to run them, and you just have to have the folder. We have a link within the notebook to allow you to upload the files, the data files onto Google Colab. You can have the data files within a folder on your Colab. Yeah.
Okay, great. So that sounds good. Eli, if you could just copy the link and share it, keep on resharing, because I've noticed people keep joining and they are asking for the link afresh. And then once Dina has made the repository public, then you should be able to clone it or even just run it online like they have already explained. And once you have it running, at least let's have people write a message of like, I have it running, so that we know, to what extent or what percentage of participants actually have it running. It would be helpful for us to know who we are moving with. Yeah, otherwise we still have, thank you, Ernest. We still have about 30 minutes rather, so the session is still ongoing, and it's important that we set up the notebooks so that you're able to do the practicals. So do not worry about time. We still have some time. But maybe as we wait for the link, Nima, you could go ahead, and if we need to go back, participants will ask where they need to go back in case when they are running, they come across some issues on their end. Over to you, Nima. Thank you for taking time.
Okay, thank you very much. So I think I can start here just quickly, and then we can proceed. For those who have been able to open their notebook, so the first step, as I've said, is to import our pandas in order for us to work with this package or the library. So write this, as you can see in this cell, import pandas as PD, and then you have to run. You click here, run. And after that, we are very sure that you have already imported pandas. So you cannot go to other step before importing this library, because we want to work with this library for data analysis. The other step is we want to read our data. So for our case in this aspect, I've said that we are going to work with a Titanic dataset, which is publicly available in Kaggle in the category of machine learning for disaster. So I've assigned df is equal to pd.read.csv with the name of the dataset. For our case, our dataset file is called titanic.csv. So when you run this part, it means you're going to read the data. So at this part, we are very sure that we have been able to read our dataset. So after reading your data set, we want to see the rows, the first 5 rows of our data, in order to be sure with the nature of the data which you want to work with. So we write df, because at this part here, I have assigned df. But for your case, if you are going to change and write something different here, it means that you are supposed to write that name here. So df.head, it will explore the first 5 rows of your data set. So when you click run, it will give you the first rows of your data set. So what if we just want to explore the 10 rows or the 20 rows? So it means you have to specify that number of the rows which you want to explore. So for my case here, I just wanted 10. For instance, if I want 11 or I want 12, I have to change and write 12 here. So if you write df.head and in the bracket you indicate the number of the rows which you want, it means this code is going to explore the number of rows which we have specified. So for this case, it will give out the first 12 rows which you have indicated. Coming to the tail, the code will help you to explore the last rows of your data set. So for this case, if you write df.tail and then you open the bracket and close, it will give you the 5. This is just defined that will give you only the 5. But if you indicate the number inside, for this case, I indicated 7. For you, maybe you can indicate 10. You just put 10 inside. And then when you click and run, it means that it is going to give you the last 10 rows of your data set. So this is the other code which I just wanted you to see. For instance, you want to explore, to list all the columns in your data frame. You just have to write df.columns. So it will give you the name of the columns which you have in your data set. So for this case, you can see we have passenger ID, survived, PC class, name, sex, age, and so many others, which it is the same as this one, as you can see here. So what if you want to know the length function? The length function, it has been used for you in order to know the number of rows, because sometimes we as data scientists, when you present your results, other people will be very much interested to know the number of samples or the number of observations which you have. So for you to explore in order to understand the number of observations or the number of samples which you have in your data set, we use LEN or length function. So when you run this, it means you can see that we have 891 samples in our data set. So that is the number of observations in your data set. And what if you just want to know how big is your data frame? In case of the number of rows and columns, it means we use shape function. So if you write df.shape, it will give you the rows and columns. So we have 891 rows and we have 12 columns. The other part is data type, and as Dr. Machuve said, this is one of the important parts for you as data scientists to understand your data set and to deeply understand the data type which your data set have. So if you write df.dtypes, it means that it's going to give you results of each columns with the data types which it concerns with. So you can see in this part here, the passenger ID, it is int, the survived int, the PC class int, the name is object, the sex object, the age is float, and so on. So this is the data type of each columns in your data set. So let me move to the slicing. What if you just want to slice your subset of the rows and columns in your data set? And this part is mainly used when you want to select maybe a single columns or a multiple columns, depend with your preference. So if you want to select a single columns and return it as a series, you just write df.name. This name is just one of the columns. As you can see here, we have the columns which it is called name. So if I just want to select that single columns and return back in form of series, we write df.name. So when I run this, it is going to give up all the names of the people who are in that data sets. And it gives back in form of series because that is my preference. But what if we just want to select more than one columns? I want to select maybe name and sex and return as a data frame in order for us to see the difference when you return as a series and when you return as a data frame. So make a note on this part here, how the series looks like, and then we are going to see what if we return these results in form of data frame, how it is going to look like. So you write df and make sure that you open the brackets. You open the brackets and then you write name and sex. These are the two columns which I want to select, and then you close these brackets. So when I run, it is going to give back the data frame. As you can see, this looks different from series. So in series, we don't have the appearance like it's look here in a data frame. So if you want your results to come up in form of the data frame, make sure that you put the brackets in your codes. So if you put the brackets, it means it's going to return as a data frame and not as a series. And this is just multiple columns. You can do as many as you can. Maybe you can return name, sex, and the other thing maybe age, and it will all work. So in case we want to return something, you just go back and see maybe you have the other code here, which it is called age, and you want it here to be included. You just write age. So it means I want to select more than one column. I want to select name, sex, and age. And then if I run here, it will give up name, sex, and age. So you can do it as many as you can. Just include the name of the columns which you want to select. And what if you want to select the rows by numbers? So you can see here, I just want to select rows by number, but make a note that in this part here, it is going to select the row which you have specified here, which it is 15, but it is going to give you up to n minus 1. So for instance, if you just want to explore up to rows number 20, it means at this part here, you have to write 21 in order for that 20th row to be explored. Otherwise, if you just write 20 in this part, it means that you are going to explore from row 15th up to 19th. So you can see I've been able to explore the row number 15th up to 19th because I have indicated here 20. It means it's going to take from 15 up to n minus 1. So if I just want the 20 row to be included, it means that I'm going to change it here to 21. So if I load it, it will give me from 15th up to 20th row. So what if you want to understand the position based on the selection of the columns and rows? So Panda will allow you to use position-based index, which is often implemented by using iloc and loc. So make a note that loc is label-based indexing, while iloc is for positional indexing. So when we talk about the label-based index, let us see by using example. In this part here, when you say loc, we expect inside the brackets, you are going to talk about the names because it is label-based index. But when you talk about iloc, we expect inside the bracket, you are going to specify the number because it is position index. So in this part here, I write df.log, and then in this part here, I write ticket. Ticket is one of the column which I just want to explore. Make a note that the left-hand side, it's all about the rows, and the right-hand side is all about the columns. So in this part here, I just specify the tickets on the right-hand side. It means I'm going to explore the columns and not the row. So when I run this code, it's going to explore and give back details, all the details about this column, which it is ticket. And as you can see, it gives out all the results here. But what if I just want to explore the same columns, which it is ticket, by using iloc? It means when I just go here, you can see we are going to start by 0, 1, 2, 3, 4, 5, 6, 7, 8. It means ticket, it is in the 8th position. So I'm going to change this code and write df.iloc, and then I specify 8, and I expect to get all the results of tickets, which it is the same as above, but I use iloc, and inside I just indicate the number and not the name as I've done above. So you can see it gives me out the same results, but here I use iloc with the number inside, while up here I use loc, which it is label index, with the name, which it is ticket. So what if you want to extract only rows, and make a note that the rows is just the inverse of that columns. As I've said that in order to explore or to extract rows, you work on the left-hand side. And in order to explore the columns, you work on the right-hand side. So for this part, I just write on the left-hand side. It means I just want to explore the rows and not columns. So it will give me details of that rows with all specific information, details on that specific rows which I have selected. So the other interesting part, which Dr. Machuve explained it very well in that introduction part, is missing values. So we are going to see how are we going to handle missing values, because this is the real world problem. Most of the data scientists, we always face this challenge after we go to collect data, or sometimes after we have been able to get the data from the publicly open repository. We found that most of the data set which has been collected, it has missing value. So how are we going to handle missing value? And it will depend with your justification. Other people, they handle the missing value by dropping that missing values. Other people, they generate a different approach. So let us see how are we going to handle such kind of situation. So in particular, any data sets, they have this missing data. And for pandas, it's treated by using none or NaN as essential interchangeably for indicating missing or null values. So pandas method for missing values we have is null, which tend to generate a Boolean mask indicating missing values. We have not null, which is the opposite of is null. We have drop NA, which returns the filtered version of the data. And we have fill NA, which returns a copy of the data with missing values filled or imputed. So what if we want to detect the null value? We have our data set here, and we just want to detect the missing value. So we just write df.isNull in order to detect the missing value. So you can see all the part which says false, 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 it means there is no missing value. But if you see true, 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 it means in this part here, in this cell, we have the missing value. So you can see at this part, it is very hard for you to understand how many missing values we have. So let us see the easiest way to observe the missing value. So we can observe the total missing value in each columns by writing df.isNull, we open the bracket and close .sum. And this code is going to give you the total missing values in each columns in your data set. So you can see the passenger ID, it doesn't have the missing value. Survive does not have missing value. But for the case of age, we have 177 missing value. The cabin, we have 687, and the embarked, we have a 2 missing value. And this is the code that can be used for not null in order to observe if we don't have the missing value in our data set. So it will give you true, true, true. It means there is no missing value. But when you see false, it means there is missing value in that part. So it's just the opposite of the first code. So how are we going to handle missing value? We're going to see different approach, as it was explained in the introduction, that other people, they tend to drop the missing value. So for this case here, I have assigned the clean data is equal to df.drop null. It means that I'm going to drop all the missing value and then to save that other file with clean data. So this is the first approach of handling missing value. So all the missing value will be dropped in this part here. That is the first approach, but we have been told that to be very sure before we decided to use that approach, because as we all know that our aim is to have a lot of data set. So if you just decided to drop the data, it means you are going to reduce the number of samples, which sometimes might be affecting your learning process. So rather than deciding to drop the missing value, the other approach which you can use, other people, they tend to use mean, as it was explained. Other people, they tend to use median, and so many other approach. But you should have the justification behind why you have decided to use that approach and why not the other approach. So for this case, because we have seen here that age, it has the missing value of 177. Let us use that as an example. And for this case, I just want to use this df age and fill the age with mean. So in all missing value of age, I want to replace it with the mean rather than dropping that cell. So I have done it, and then if I write df is null sum in order to know the number of columns and specific columns with the missing value, I expect that this part age will not be there because I have filled the missing value with mean. So if I run here, you can see now age, it has 0, doesn't have the missing value because in all missing value of age, I have replaced it with mean. So the last part which I want us to see is descriptive statistics for data. And in this part, we use the function which it is called the describe. So describe function, it will give you the list of 8 statistical properties. And this is one of the very important part because other people will be very much interested with statistical part of your data in order to understand it in details about the mean, the maximum value, the percentile, and so forth. So if you just want to understand and explore your data set in part of the descriptive part, you need to work with this function, which it is called describe. So if you write df.describe and then you open the bracket and close, it will give you the summary statistics of your data set. So for this case, you can observe that it ignores all the columns with names. For instance, the name, it is not there because it is not possible to come up with descriptive statistic of names. So it will give you descriptive statistics of all columns with numbers. So you can see the count, the mean, standard deviation up to the maximum. So what if you just want to obtain descriptive statistics for particular columns? For instance, I just want to understand the maximum age. So you just write df age.maximum and then open the bracket and close. And then when you run this, it will give you the maximum age in your data set. So it means in that Titanic, the maximum age of the people who are there in the Titanic, the maximum age was 80, which it is the same as the results which we have found here. What about the mean? If you just want to understand maybe the mean of the fare for those people who entered in that Titanic, then you just write df fare.mean, and then when you write, it will give you 32.2004 and so on. So this is the same as when you just come here, fare, and just you look at the mean, it is the same results here. So that's all for pandas for data analysis. I would like to welcome Dr. Machuve to proceed with exploratory data analysis. Thank you.
Yeah, thank you, Neema. If you can allow me to share my screen. Yes, so I've seen a lot of questions coming up on the chat. You can run actually the notebooks either locally, where you'll be forced to install the Jupyter and the pandas, but alternatively, you can run the same notebooks on Colab. So here I'm connecting to Colab. I've loaded this notebook on exploratory data analysis, and also the data set, the folder which is called data, is also on the Google Drive. So pardon me, so here we can import the libraries. We are running it on Colab, and here for the Colab environment, I just commented this out. If you don't have the data set on the Google Drive, then you can run this code, which is actually on the notebook now. But actually, you mount the drive, okay, and then you should be able to run it. So you can upload the notebooks and the data folder onto your Google Drive, and be able to run the notebook on the Google Drive. So here, the first, you import the libraries, no need of doing installation, or using resources from your machine. And here now, this is the path where I have the data set. I have it on the folder data, train, test, and the variable definition. So here I'm able to load the files into a pandas data frame. And then we start doing some basic exploratory data analysis. Here we have like, what do the variables mean? So we have a file called variable definitions.csv, which actually kind of describe what these variables: gender of respondent, gender of the interviewee, whether it's a male or female. So now here we want to view the first 5 lines of the train data set, where these are the columns that we have. We have like the bank account. The training data set has the target, yes or no. And here we want to preview the rows test data set. And also, as basic data exploratory analysis, how big is the data set? So we use the shape, train.shape. We are able to understand that the training data set has 23,524 rows and 13 columns. 13 because we also have the target values, whereas the test data set, it has 10,000. And here we have the columns arranged horizontally. At times, it might be a challenge to view them. So we use these train.columns to see them as a list. So these are the different columns. But if we use train.info, we are able to see more information, like the data type. Like these ones with object, that means they are those which are categorical or string data type. Int for the year, those are integers. Household size and age of the respondents, these are the numeric data types that we have. And here it even shows like we have data with 13 columns, and actually we are lucky here. I don't think whether there is missing values, we can confirm. You see all the columns are clean, but Nema showed you earlier how to do all the missing data. So here, what I want us to get a glimpse on, histogram, we say it works on continuous variables. So when we look here on the info, we see we have the age of the respondent, household size, and year being the numeric values. So those are the ones that we can use to visualize using a histogram. So if we look here to try, we use the Seaborn library to plot the histogram of the age. So what sense can we make from here is that we have the highest number of respondents around this age, about between around 30s. Okay, so we can see it visually and be able to make. And for scatter plot, we see it looks on to relationships between two variables, and we only have 3 which are actually continuous. So let's see, do a scatter plot. So CNS here, when we did the import of the libraries, is actually the Seaborn library. Okay, so we imported it with an alias of CNS. So when we do the scatter plot between two variables. We could see the age of the respondent and the household size. We can do a scatter plot. And actually having them vertical really infers that maybe there is no correlation between the household size and the age of respondent. And then when we come to the bar plot, actually they're useful for understanding how categorical groups are different with respect to a continuous variable. And here we can look on to, let's look on to the, sorry, I ran it before. Yeah. So we have like the gender of the respondent and the age of the respondent. We do a bar plot. So we have the categorical value is the gender, male or female, and their age. How do they relate to one continuous variable? So we have the male and the females. Now, when we look on to the categorical values, we can equally do look onto the how are these respondents distributed across countries. We collect the data from Kenya, Rwanda, Tanzania, and Uganda. So we do this plot to see how the distribution is per gender of the respondents across the countries. So here you can see what insight can you draw from here. We can see that most of the respondents are females, and most of these respondents are coming from Rwanda. So we see that most of the, and now if we want to see like how many there are exactly, because this is just a visual, you can run this pandas command on value counts. So we see that 8,700 respondents were from Rwanda. But how many females these are and how many males? So you can further run the same and run this code to see like, okay, from Rwanda, the females were 5,204 and males were 3,531. So you can make more, you can understand your data more. That you have here respondents from Rwanda or from Kenya being 6,000, but you can further be able to see how many were actually females and how many were males. You can even look onto what were the locations of these respondents. So that is part of the EDA. So here you can use this location type. You see most of the respondents came from the rural area and a fewer in the urban. So you are able to understand whether they have access to a bank account. You can be able to visualize before you run your model. So you see here, you have most of the respondents without a bank account. A few do have, okay, a bank account. And actually, what are these values? How many actually? So only 3,300 respondents have a bank account, whereas 20,000 do not have a bank account. And then you can even do a box plot, okay? Of the gender against the age, okay? And here we are able to see the average age of these respondents for the females and the males. So the average is around 38, and here for the male is a bit higher. But you are able to do that, and you can even do the summary statistics that Nima responded earlier, but now for the age here, we see that the mean age is around 38. And here, when we look onto the box plot, it's around the same for both male and female. So you are really able to get more sense of your data. And after you have run these statistics, next is to do feature engineering, where you are able to transform the variables and do machine learning, run machine learning models to be able to predict and see the performance. I'm sure we will have those also updated on the repository by end of this week. So, but these are actually that you can do exploratory data analysis to confirm what you have done, and run those after you do the data cleaning to get more understanding of your data and make the right decision before you are able to run your machine learning models. So actually, that's the end of our tutorial, but we've been able to share with you how you can run these models, or run these Python notebooks both locally on your machine, or you can use them you can use them you can run them on Google Colab. So that's it from us, in case there are any questions. And I've also shared the link to the Colab on the drive, on the chat. Thank you.
Great, thank you very much for that, for the materials that you have shared. I want to hear from the participants now. Has everyone been able to access or to run the notebooks? We still have about 6 minutes, so let's figure all that out so that you have your code running for later in case you want to ask or to do more during the networking session. You can type in the chat if you're having any trouble and you need Dina or Nima to help you. Or maybe I should help. Okay, someone says I need help. Could you be specific with what kind of help you need so that then you're guided? Just type in the chat. There is a question for you, Dina. I don't know if you can see in the chat, or would you like me to read it for you?
Yeah, Nema, can you go for that one? Yeah, the one I'm feeling now with me. Nema.
Hello. I was trying to read the question. Filling null values with mean. We use the mean of the feature with missing value, or I'm not so sure if I get it correctly, but how I can respond is that when we want to fill the missing value, for instance, the age has got the missing value, you can decide to fill the missing value maybe with mean or with median. It will depend with your preference, but with justification. Why you have decided to fill the missing value with mean, and why you have decided maybe to use median, and so forth. So it is not like a formula like you're supposed to fill the missing value with mean. No, it is not like it is supposed to be that way, but you can decide because there are different statistical approach of handling missing value. So depending with the nature of your data set, you can decide which approach will be appropriate based on the nature of your data set and the reason behind why you have decided to fill the missing value, maybe with mean or with median or wherever. I think I've responded it.
Okay, perfect. There's one about, is it possible to analyze Excel data directly or convert it to CSV? If by that you mean, oh yeah, go ahead for it. I was just going to answer.
yeah, it is possible to explore the different version of the data. It is not necessary to be CSV file, but make sure that you indicate that extension. If you're going to use the Excel, it means you are not going to write CSV. You are going to write the short term of Excel there in the data at the time you load your data set. So it is not necessary to be CSV file.
There is another one right there. Is there any other way of reading the file apart from the pd.read function?
I'm not so sure if there is any other way. Maybe Dr. Machuve will assist on that part.
Yeah,
but for
actually,
my case, I think.
Yeah, it depends on the file format. If you are reading tabular data, it can be CSV, it could be Excel, it could be text file. So normally we use the pandas library. But if your data set is images, we also have different methods of loading images using those. If it's an image data loader, we'll see that in computer vision session, the deep learning. So it all depends on your data set. Is it in text file? So when using the pandas library, you mainly focus on the tabular data, which could be Excel, CSV, text file, or other tabular format which are supported by pandas. So for our case, we say pd.read_CSV. It could be read Excel, or read text, and you are able to import it on using pandas. So it all depends on your source files. What format is your data in? Yeah.
All right, cool. Thank you. Does feeling of missing value with mean also work with Boolean values? That's the next question.
That falls on what we didn't cover, but we'll have it documented on the repository. The Boolean values actually falls onto categorical data. So you do encoding. You can encode it to 0 or 1s, meaning 1 means true, 0 means false. And once it's numerical, then you can see what you can you undergo then the same process to check for null and be able to fill in if a missing value was either a true or a false, then you can do the fill you can make the decision on how to fill in the missing data. Yeah. So a next step when dealing with these categorical data is that you have to encode it, transform it. Yeah.
Okay, perfect.
Yeah.
Thank you. I don't know if there is any question that we have skipped that was up there. Maybe someone can. Okay, so one has just come in. Can you give more details on how to choose the best way to handle missing values? For example, with numeric value, median versus mean. Okay, we have 1 more minute left, but I would like that the questions keep coming. Even if this is not answered now, it will be covered in the networking session. So continue running your notebooks and then write down your questions, and then later on after the presentations and going through the live tutorials, the facilitators will be available to actually to attend to your questions in different breakout sessions when we start the networking sessions. I don't want to take more time now to get into the time of the next session. So let's give a round of applause to Dr. Dina and Dr. Nima for this great tutorial and presentation that we have just gone through. You can just use your emojis to put your claps in the chat. And yeah, thank you very much for this. I will go right into the next session. And like I said, note down your questions and they will be dealt with later. So, Ernest, I know you're already online. Did you try sharing your screen? I see a hand, but again, if it's about the tutorial that we just finished, let's keep it for the networking session. Ernest, are you there? Oh, perfect. You're already sharing the screen. Okay, cool. So we will get right into ML and computer vision. And for this session, Hannah, I don't know if you can hear me. Hannah will be the one to handle questions when they come in and any other issues that may come. Maybe on a break for a bit. Hannah, can you hear me? Just want to be sure that you can.
Yes, ma'am, I can.
Okay, perfect. So Hannah is going to be your moderator for the next session. You're welcome. Ernest, please get started. Thank you, everyone.
Yeah, sorry, wait. Hello, can you hear me?
Perfectly, yes.
Great. Okay, cool. Yeah, so the session is on ML and computer vision. And I wanted to quickly, all right, there you go. Start with ML. So ideally this session is mainly on computer vision. I suppose we have some understanding of machine learning already. But, machine learning, as we probably all know now, it's really about getting computers or programs, or more generally to learn and infer or make inferences from data without the need of explicitly programming them. So previously you had to, program something to do something. Now you want to learn from the data what you can infer. So you assume there's the assumption in machine learning is that there's an inherent data generating process. That data doesn't come from, is made probably not random. That data is generated based on some inherent data generating function. And so the goal of machine learning normally is to learn this function from the data. And based on that, you can infer things based on data with a similar distribution. Okay, so here we have two components. So we have data, and then we have the learning process. So that sort of is there's a lot of machine learning in there. So what are some examples? Maybe some easy ways of getting to know this is things like spam filtering. So this is quite common in your emails. So you get emails, some go to the inbox, some go to the spam. And right now you have also these, if you use Gmail, you have several tabs. Is it notifications? Is it social media? So the emails are sort of distributed. And behind this is a machine learning algorithm that does that. So it has been trained over several emails over time, and it can do this. The things like speech recognition, again, this is part of machine learning, which is part of natural language processing, taking some speech, and then the algorithm can look at that speech and decide what action to do. Things like web search, very common now. Put in a search term, and the web browser generates some results from that. Again, behind that, you find a lot of machine learning. So in all these examples, movie recommendations, self-driving cars, automated diagnostics for crops, which is more closer to home. In all these applications of machine learning, you see the component of data. And here the data could be text, could be speech, could be emails, could be images of crops, could be inputs like from a camera, from a LiDAR, for self-driving cars. So you see that there's a certain component of it, which is data, which is in different formats. And there's a process sort of learning, which is sort of the machine learning part. Okay, so there are many types of machine learning now. So we won't drill into all the types. We'll focus on supervised learning. I think most of the examples you'll do in this summer school will be tied to supervised machine learning. And here supervised, we mean for all the data we have for training this model, we have a label for the data. So the data is labeled. So if we take our example of the email filtering, spam filtering for email, our data would be a correct email and then a label that says, okay, this is a legitimate email. And then you'd have spam email, and then you'd have a label saying this is spam email. So this would be the data we use for training the model. So the data is labeled. All the data has a label. If you're thinking of an example like crops from images, then for each image, you have a corresponding label of a disease. So this image is an image of a leaf of a plant that's diseased, and then a corresponding label would be something like it has disease with a viral disease. So this is supervised learning. Supervised because we also provide the labels to the training algorithm with the data. Right, so that's labeled data. So we have known outcomes, and then the modeling, or the quote unquote the machine learning is really trying to fit this data to the model, right? And normally you assume some sort of hypothesis. Is there some sort of linear relationship? Is the data generating function linear? etc. Right now, we don't do much of this. We sort of put them in deep neural networks, and they sort of figure out this data generating function. But this is modeling. You get the data and some algorithm, and then you fit the data to this model algorithm, and then you call that a trained or fitted model. Okay. So that's sort of the big component in machine learning. So maybe we'll talk about data a little bit more. So we've seen different types of data from the examples of machine learning that we've looked at, audio data, textual data, numeric data, images. So there's lots of varieties of data. So we require some way of representing this data. So you can imagine from the tutorial from Dina, so how that data, you have a CSV, you load it in, it's easy to compute on that data, it's numeric data. You can see how that data can be applied to a mathematical formula, and then some processing. So we need some representation of this data. Maybe it's audio data. When you speak, how does that data translated into data you can work with Python, or text data, or numeric data? Numeric data is easy, and maybe images. So you need some way of representing this data. So that's one. And representing it in a way that you can build a reliable machine learning algorithm. Then you can start thinking of representation learning. How do you learn correct representations from this data that can be informative of your machine learning algorithm? All right, so what's a representation? So a representation is a compact vector, normally. A compact vector, compact representation, normally a vector or the tensor. Well, the tensor is a vector that describes the input data. Sometimes you refer to it as a feature, as we will see. So for example, this could be an example of a representation, this vector X. And so if you think of computer vision, which is sort of the main topic we want to deal with here, what are those representations? So computer vision is part of machine learning, part of AI. Machine learning is also part of artificial intelligence more broadly. But computer vision is more focused on dealing with specific types of data, mainly image data and video data or visual data. So when you're doing machine learning with that type of data, normally this is the field of computer vision. So in recent times, you can convert several types of data to images, and you can use computer vision to do the machine learning, to do the learning. So an image representation, so you need some sort of representation of images. So video is sort of a series of images. If you take a video, it's really a series of frames, which you can think of them as images. So an image representation, in this case, you could think of it as a compact vector that describes the visual content of an image. So how do you capture the visual content of an image? So that's what the representation would mean. And this could be global, where the representation covers the whole image. And I'll give some examples, or it could be multiple local representations of the image. So our goal in this tutorial, actually, the focus is on computer vision, but mainly on practical aspects of computer vision. And for this case, we'll consider the task of crop disease detection. So it's not a general tutorial on machine learning and computer vision, because there are several good tutorials online and courses, and all courses. Also, the topic is quite wide to cover in 45 minutes. So here we'll focus on computer vision, but the practical aspects, and we'll focus on this problem that you'll also do in your lab of determining crop disease. All right, so these representations of images could be local. So for example, if you look on the image on the left, for some reason my pointer can't be seen, but on the image on the left, these are called sift features. If you look at the leaf on the top left and its representation on the right, so these were very common features back in the day. These are called sift features. So each of those red points is a point of interest, key point of interest, where the algorithm thinks there is an interesting feature of the leaf. And then the one down are called orb features. And again, this one picks interesting points on the leaf where it thinks there's something of interest, there's a feature of interest. So here your representations are in different places. So you have very local representations of the image, identifying different areas in the image which are of interest. The one on the right is sort of an example of global representation, where for each image you're representing it as a waveform or a vector representing a color histogram. So if you take that graph down, it will be a vector of numbers that represents a histogram of color. So you could represent, for example, hue, and this would be representing how the color varies in that image. So that would be a global representation on the right, where you have one vector representing the whole image. On the left, this would be local representations, where you have multiple key points representing different parts of interest in the image. And what can you do with these representations? Basically, you can do things, machine learning, basically. Classification, where you're given a set of classes or labels and an image, and you assign a particular class. It's sort of what we've talked about, supervised learning. You can do things like detection, segmentation, where you can look at different representations to detect or segment out a part of the image. You could do things like video understanding, track objects in time, you do image captioning and generation. You can do multiple things with the representations. So here the key message here is that you need some of representing your data in a way that you can sort of compute over it. All right, so let's look at our task of image classification, which is sort of where crop disease detection lies. So given some representation of an image, what we want to do is build a classifier model, machine learning algorithm on top of those representations. So it's similar to what we looked at previously for spam filtering. For example, here the data is just represented differently, and then you run a normal machine learning algorithm over that, quote unquote. So what does it look like? So basically you have some raw data. In this case, it could be leaves of the plants, and you want to extract some sort of representation from them. You could also call it feature extraction or extracting representations. And these representations are labeled. You get some labeled data, i.e. disease A, this leaf is represented like this, and that corresponds to disease A. And these visual representations are used to fit a model. So you fit a model, and once you have the trained model, then you can do prediction with unseen data or new data. So we get the unseen data, get the representations from that or some sort of features from that, and then you can have a prediction. Prediction can say something like, okay, this leaf represents a healthy plant, or this leaf represents a diseased plant. Right, so how do you extract features? So one way of getting representations is to do them manually by extracting them, a process called feature extraction. It was very common previously in computer vision and a lot of machine learning. Right now, it's not very common with the advent of deep neural networks. But this process involves extracting handcrafted image visual representations. So for example, you could look at a leaf and say, okay, like the leaf on the top right, you could say this is an example of a leaf that's diseased with cassava mosaic disease. And what that disease does is it disfigures the leaf, the edge of the leaf. So you can see the edge of the leaf is disfigured. Also, it eats away the chlorophyll in the leaf, so the leaf is yellowish. You see those yellowish spots on the leaf. So here I'm using the domain knowledge of the disease. And so, okay, now what I want to do from leaves is extract features that represent these phenomena. So I want to extract some of knowing that the leaf edge is not smooth, and some of knowing that the color of the leaf is changed. And so you could do things, and this is where things like sift features come in, because you can sort of extract the phenomenon happening that the edge of the leaf is deformed. You can use color histograms to extract the color features, the phenomenon that the leaf is decolorized by this disease. And once you have that for healthy and diseased leaves, then you can build a machine learning algorithm over that. So extracting features, the biggest challenge with that is you need domain knowledge. You need to know the disease, for example. You need to have some intimate understanding of how the disease manifests, in this case, on a leaf. And this could be hard. Okay, so the other option is learning representation. So the first one was extracting representations, but you could also learn these representations. And this is where it becomes quite interesting with the sort of recent advents in computer vision. So here there's less designing of features, less extracting, less thinking, okay, does it decolorize? Is the edge bent? I don't need to know all those. Here, the idea is to design a model that can learn these representations, which are best suited for the task at hand, in this case, classification. So it relies on sort of quote unquote showing the model example of desired output and desired inputs, and allow the model to learn suitable representations. So this is really the basis of neural networks, that they offer this unique advantage that you don't need to handcraft features, that you provide it with a lot of data. And then from that a lot of data, these networks, these deep neural networks, learn a series of representations of your data and relate that to your label. And based on that, you can build these very interesting computer vision models that can have high performance on visual tasks, like classification, for example. Okay, right. So what does this mean for our tasks? So this is our task here. So we have these, for crop disease detection task, we have a 5-class problem. So we have these leaves each represents a different class. So the middle one is a healthy class, an example of a leaf from a healthy plant. And then the one on the left is CMD, represents cassava mosaic disease. And the next is CBSD, which is cassava brown streak disease. And then the fourth is cassava bacterial blight. And the last is cassava green mite. So these are viral diseases in cassava that manifest on the area part of the plant, on the leaf. And so experts can sort of look at them and determine that this is the disease. But for an ordinary farmer, this may be complicated. And so our goal is really to design or to build a model that can take a leaf and determine which of these 5 classes that leaf belongs to. And once we build this model, then we can train it on unseen images. All right, so yeah, so I guess this is what I wanted to say with in terms of representations, why deep neural networks are so important. So there's a branch of deep neural networks, convolutional neural nets. So I won't go into deep into this, but there's a session I think on Wednesday where I think you'll go through the basics of deep neural networks and you'll understand this in detail. But this is not, you don't necessarily need this to build algorithms. Things have sort of moved ahead quite a bit, but it's good knowledge to know. But the idea of deep here really is that you have a layered architecture. Deep means it has several layers. So you have an architecture of several layers of this model. And in each layer learns sort of a higher level representation from representations learned from the previous layer, right? So if you look at this image on the right, the lowest level pixels, so the lowest level are really pixels in an image. And from pixels, you can learn things like edges. So the edge part would be one layer or a bunch of layers of a neural network. And then from edges, you can learn a more complicated representation like object parts, right? So if you look at this image, I think this is for faces, you can start seeing eyes, which eyes are sort of made from a bunch of several edges. And then upper layers or lower layers, depending on where I looked at it from, you can start getting object models. So things like faces start to appear, or eyes, or a nose, and this kind of thing. So that's the whole idea of deep, that you learn one set of layer of representations. The next layer uses those representations to learn a higher sort of level of representation, and so on and so forth. So the deeper the architecture of your neural network, the more representations it learns, and the better representation it learns, the better your model is for doing the tasks you want to do, like classification. Of course, there's a disclaimer on how deep it can be and some ways of making it deeper and issues that come with that. But the idea really is that it's layered so that representations learned provide an input to other layers to learn, higher representations. All right, and these convolutional neural nets, sort of a class of these deep neural networks that has these convolutional layers, and so you have CNNs, or deep neural networks have a bunch of layers. So these layers, the reason why they sort of learn consecutively higher and higher representations is because they're slightly different layers. Yeah, they have different sort of functions. So you have multiple layers. You have fully connected layers, you have convolutional layers, you have things like activation functions within the pipeline. So if you look at this image on the right, you can sort of see from an image on the left K, you can sort of see different ways in which representations are extracted, and different things like activation functions, subsampling, pooling layers. There are things like residual networks or residual connections. And you sort of go deep into this in the deep learning fundamentals on Wednesday. But the idea here really is that from the image, you're generating representations all through this deep neural network. And at the end, you're using these representations with a label to build a basic machine learning algorithm that just takes these representations with a label and learns some sort of and does a simple prediction classification. Okay. So there are, right. So training CNNs is, so it has become easier over time because people have kept discovering new ways of doing it. But if you look at any of the conferences like NeurIPS, I mean, the amount of papers that come up with people adding on to the body of knowledge of how to train, for example, CNNs or deep neural networks, there's a lot of information, a lot of knowledge. But as we'll see in the lab, I think we're also getting an increase in tools. So tools and platforms that are able to encapsulate a lot of this knowledge and hide it from you. So you're increasingly able to build stronger networks or build really good models without a lot of the tweaking of these things. But tweaking these things is definitely important if you want to train a new model and you want to be able to monitor the performance and tweak it, etc. So there are several considerations. Some are to do with loss function. What kind of loss function do you want to use? Type of regularization do you want to use? And over time, people have sort of figured out that, for some applications, these, for example, loss function, this loss function is good for certain applications and etc. So reading the literature can be a good help in doing this. But these are ways of, if you want to train a CNN, particularly from scratch, these are ways you can tune it. These are things to think about when you want to tune it. Learning rate tends to be a big issue. So selecting an appropriate learning rate is important. Then other things to do with data. You need a lot of data, but also for processing the data is a key consideration. But perhaps the biggest consideration is this idea of transfer learning or fine-tuning. You want to build on knowledge that other people have built on, right? So if you're training a crop disease model, maybe there's already one on cassava disease detection. How can you transfer some learning from that to train yours, which is on beans, for example, determining diseases in beans? Right? So this is the idea of transfer learning. I find it one of the biggest sort of revolutions. And we'll see that even when you have less compute, less images, this is still a fantastic way of leveraging external learning to build better models. Okay. So crop disease classification. So the idea here is given a leaf image. You want to predict a single class of disease from among 4 classes. The 5th class being a healthy crop. And these images that you see here are the sort of the worst type of images we could get. So while they look a bit fairly distinct, there's actually a lot of variance in the, or limited variance in the actual classes. All right, so what's the big picture? So the big picture really is monitoring crop diseases for food security, for example, like cassava, is quite critical for the developing world. You know, you get all these, for example, cassava tends to be a big disease in sub-Saharan Africa. So understanding how a farmer can take can have an algorithm that predicts disease is important. So, for example, this particular problem cassava is mainly grown by smallholder farmers. And smallholder farmers are not people with a lot of computers sit down and take images and process them on the server in the cloud. So this is not going to happen. So even in thinking about this problem, we know that smallholder farmers at best will use a smartphone. So the idea of building the model is also constrained by the limitations of the compute it's going to run on. So you want to build it for a smartphone. So lightweight, small model, effective and robust. But the bigger picture is really that this can contribute to some sort of improvement in their livelihood. Okay. Yeah, so the challenge really is to diagnose disease from images taken from a smartphone and hopefully have the algorithm on a smartphone. So our problem is further constrained. So crop disease detection on a smartphone using images taken from a smartphone. And what are some of the challenges with this kind of problem? So it's a fine-grained task. So these are, what's a fine-grained task? So these are computer vision tasks normally, where you have small inter-class variance and large intra-class variance. So what this means is, so this may not be very good images, but what it means is, so between the classes, for example, if you look at CGM and CMD, there's limited variance. So you can easily confuse one for the other, or CMD and CBSD, or CVB and CMD, right? So it's very hard to distinguish between the diseases in the different classes. That's one feature. The second feature is that for each class, for example, if you look at CMD leaves, if you get 100 of them, there's a lot of variance in how CMD may manifest, particularly for leaves. You see these leaves have rich backgrounds. Some may be on a background that's brown, others a background that's facing the sky. Others have 7 lobes visible, others have 1 lobe visible, the leaf. So there's a lot of variance in these kinds of, in the classes themselves. So it makes the problem a little bit harder. And you can go and do some research on fine-grained computer vision tasks. Secondly, there are lower quantities of labeled data. So you may be able to get a lot of data, but may not be labeled. To label this data, you need an expert from the agriculture sector to sit down and go through all these images, which tends to be quite complicated. Not complicated, time intensive. And so expert labeling is cumbersome. Sometimes they're wrong labels. Sometimes the disease manifests, 2 diseases manifest on the leaf. You also get class imbalance because these diseases manifest differently. The prevalence is different for different diseases. So maybe just to hone in on some of the issues. So ground truthing is a problem. So ground truthing is a process of labeling. Given an image, how do you say this is an image representing disease X? Sort of ground truthing. What does the expert say this is? So you get a problem. You have field images look sort of like the one on the left. So it's an image of a leaf, but you can see in the background there's a healthy leaf. Then in the further background, you see that you have the ground. But if you look at the images, especially the ones that you will be using in your lab, they look like the one on the right, right? So well cut out, well curated, well centered, So this, this tends to be a problem, especially when you're building an actual app to deploy. Right. So what are other problems? If you look at the image on the left, so as I said, you could have a plan that manifests two diseases at the same time. So you have the first leaf up, it's cassava grade mite, the one down has some, so these are leaves of the same plant. Actually, the one down is cassava mosaic disease. This label here is wrong. Cassava mosaic disease, and then you could also have severities. So the severity of the disease, how strong the disease is. This is severity 4, severity 3, these severities go up to 5. So labeling can be quite a problem because you need to label to get images to train a machine learning model. And so this is problematic because the image the farmer will take will be like the one on the left. And so you want your algorithm to be able to be robust enough to handle such an image. All right. Then the other things, how do you actually label? Do you provide these boxes and say this part here is cassava mosaic disease? Do you actually go in and say, okay, this area manifests cassava mosaic disease, for example? Right. So these are things you need to determine. So it can be fairly complex to do even simple things like labeling for these types of problems. So this is where you need to sit down with the experts and see what makes sense. All right, so what's our strategy? Coming back to training. Our strategy is to use a pre-trained model. So get some model that's already been built, maybe on ImageNet, and then train over that or fine-tune that one with our data. So this process is called generally transfer learning. And why does it work? Because, as we said, in deep neural networks, the different layers extract different representations, from basic representations like pixels to edges to objects, etc. So if you look at images, for example, on ImageNet, where you have cars, bicycles, dogs, etc., and look at images like leaves, the first couple of layers, for example, you could assume they're extracting the same things. You want it to extract edges properly. You want to extract pixels properly. You want to extract, edges which are combined properly. So you can extend your imagination and sort of think that, yeah, if I want to extract features from leaves, if I've already extracted features from a large data set like ImageNet, maybe I can use those first, for example, layers to extract edges, to extract different representations from the image that could be helpful for classification. Then on top of that, why we call it fine tuning is on top of those, then I add specific images of cassava, and then it sort of fine tunes it to the problem of cassava. Maybe says, okay, cassava mosaic disease, okay, I've extracted edges, objects, but now the color looks like it's a bit yellow here. The leaf looks like it's been, the edge is not smooth. And so that's where fine tuning comes in. You're fine tuning an already pre-trained model to your specific problem. In our case, specific to cassava disease detection. And this has been shown to work quite well. And we'll see that it works well in the lab as well. And then the other part of the strategy is to leverage some best practices. So I'll leave this to you to sort of read and do. And if you can use some domain knowledge, especially domain knowledge or any other thing, closed domain data. So there's several strategies now to use even unlabeled data, this kind of things to extract representations and then use that in the classification. So one key thing for robustness, especially if you're going to deploy this, is to add also an unknown class. And we'll look at that. That tends to be quite important. All right, so this pre-training. So we are comparing pre-training to training from scratch. So these, so you could train from scratch, which is basically get your images and train a model from scratch, or you could do pre-training where you build onto a previously trained model. And there are different cons and pros. So the expected performance tends to be high if you're pre-training, right? You tend to get high because you're utilizing representations that are already learned from a trained model. So pre-training tends to give higher performance. And then the data required, so you need a lot more data to train from scratch. If you're going to train a model from scratch, no, wait, I can explain this slide wrong. Yeah, so to train from scratch, you need a lot of data. And to pre-train, you don't need a lot of data. So you have some sort of continuum. So if you know what data is required or how much data you have, then you could train from scratch. You tend to have higher performance. I think this is what this slide actually means. That if you train from scratch, you get expected higher performance compared from when you pre-train. But this requires, again, that you have a lot of data and you have a lot of compute. Okay, so I see we have 2 minutes left, but this is the last slide basically, and then I'll just introduce the lab. So what do we want to do with the lab? So we want to use several tools. As I said previously, things have advanced quite a bit that you can use. There are tools that make things a lot easier, quicker. So I'll use TensorFlow Model Maker, which is a tool that can build a model and build it in such a way that you can export it and put it on a phone. So it's built custom for targeting things like mobile devices or Arduino boards or that kind of tech. Then you have TensorFlow Hub, where you can leverage state-of-the-art pre-trained models. So it's a hub where you can get all manner of models to do all kinds of things. And so you can leverage those and select some which you want to fine-tune if you have a small data set, for example, or low compute. Then you also have TensorFlow datasets, which are curated datasets. And so these, you can use them to get things like the unknown class, if you want to introduce an unknown class to your data, or to try different datasets. And yeah, several other tools. Okay, so I'll just share introduce the lab. It's a link to this thing, and then I can end there. All right, I hope you can see my screen again. So, yeah. Oh. All right, so this is the lab, and the lab, maybe I should post that too. And put that in the chat. Right, so I'll put the link in the chat. So this lab uses a Colab, but it's a normal IPython notebook, the one that was sort of talked about in the last session. All right, so the goal is to predict disease in cassava plants from images of their leaves. And what we want to do here is explore building this thing with some of the latest tools in TensorFlow. And the goal is really to build something that you can transfer to a phone later on. To quickly apply transfer learning to minimize compute. So one advantage of transfer learning or fine tuning is that you can minimize compute because you don't have to train, a million images again. You can use the trainings that were done on those images, for example, like ImageNet, and you take that trained model and build on top of it with the limited data set that you have. And then we want to build some robustness into our model, and really that's adding another class, and and then use TF Hub, build some resources that are available for this kind of thing. So your first task,
if I may interrupt you for a bit, you actually have up to 1145 EAT, which is 1045 CAT. So if you want the participants to first load the notebook and go along with you, you still have a bit of time.
Oh, okay. I thought I thought I was over by 2 minutes. Okay. Yeah, so anyway, so participants, I don't know if they can, if they have loaded this, once you load it, you can download the resources at this GitHub link. Are there any issues with the loading this, getting the collab? So the collab, you may not be able to edit it directly. So what you do, when you get the collab, you can go to file and save a copy, and then you can edit your copy. That will be the way to do it. So if you've managed to load the collab, just give us a heads up. All right. Great. Looks like we're in business. Okay. Yeah. So yeah, so you can clone, once you have it running, you can just I think we went through this with I don't know if I need to run this as well. So one thing to do, once you have your model, once you have your collab loaded, is, so why do we need to use collab? So collab has a free GPU resources. So what you want to do, I think I explained it to you. Did I not? So you want to go to runtime, and you want to change the runtime, and make sure you're using a GPU accelerator. So this allows you to train your models faster, to utilize the GPU. So things have improved over time. You can get a free GPU. You can get, as you see with Model Maker, it's quite easy to train models now. So you should be able to do it very easily. All right, so if you've downloaded if you clone the repo, and you should get all these things. I should do it as well. Right, and then what you want to do is install this Model Maker. So we're going to use this Model Maker toolbox in TensorFlow. So it looks something like this, and TensorFlow Lite Model Maker, and it has several examples. And it's very simple. As you can see in this example, you basically load your data and basically build a model with one line and train it, and then you can export it to a T-Life TensorFlow Lite version. So it's quite straightforward. Okay, so you need to install that and install data sets as well. Yeah, the model maker spits out a lot of stuff. All right, so once it's done, you can just hide this output from this cell because it sort of fills up everything. So you can just click this X and all that output will be hidden. And you need to sort of install or import these other sort of things. TensorFlow, of course, TFDS, which is TensorFlow datasets, TensorFlow Hub, and then a couple of things from the model maker. Then you have a helper function here. This basically just prints out the images. And you can always click there and hide it, but you need to run it so that it's able to print out your images. Okay. Right, so here we're defining the problem again, in case you didn't get the problem. So we definitely want to tackle images, leaf images, so we have to use computer vision. And one key thing about images is that in this African context, this unique data set transcends languages. So it's, images is quite interesting. So imagine, like in Uganda, we have over 50 unique languages, dialects, and languages, spoken local languages. So if you want to build an app that, for example, for crop disease detection, and you want to translate it in all these languages, becomes quickly unscalable. But if you're using images, images tends to, if you're explaining to people images, it's sort of a universal language. You can say just point the phone to a plant and click this thing, it takes the image and spits out some sort of disease or some big red X, meaning this is diseased, and green meaning it's good. And the farmer can sort of take it on from there. All right, so here's our data set. We have a small data set so that this sort of lab can go on in real time. So here are the 5 classes. You want to be able to load your data so this thing comes with the GitHub. So when you clone the GitHub, you have this sort of data, and you're using data loader, which is again some library from this TensorFlow Lite model maker. And you can split your data. So once you have the data loaded, you can split your data. And if you want to know how this data should be formatted, if you have your own data, it's really simple. There's a I mean, you can wait. I think it's somewhere here. Right. Anyway, the way you do it is for each of your data, you have your data, and you can have, for each class, you have a folder with the name of that class, and inside that folder, you have all the images of that class. And if you examine the folder, this folder PD, if you examine it, works. So if you examine this folder, you can see each of the folders under this is a class, and under each of those classes you have the images. For example, you have a bunch of images representing that class. So that's the only way you need to represent your data, and then you can call it, you can split it, train, test, split, and then it spits out this. We can use our helper function to display a bunch of images. So you want to see what sort of images you have. And yeah, so it sort of gives you an example of images you have and the different classes. So you get a sense of what the different classes look like. So you can see from this that there tends to be a lot of variability interclass, right? Intraclass, sorry, within the class. So for example, if you look at CBB here, this is what it manifests at, but you also, this is CBB, right? So you can see there is a lot of variance. Yet you can see CMB and CGM. So these are quite close. So there's a lot of interclass, low interclass variance and large intraclass, which makes it a fine-grained problem of sorts. All right, so modeling. So modeling is the easy part. So with Model Maker, you could, modeling is sort of how do we fit this data to a deep neural network. Okay, I hope we are still together. So one way to do this is you can look at previous notebooks. So previous notebook is this one here. And in this one, we're doing things from scratch, from the basics. So we had the same data, and we try to build a model from scratch. So how do we extract features, CNN? So there's much more information here if you want to follow this notebook. So this, you can access it from here. And in this notebook, we sort of did data generation, and we built a model. So we built a convolutional neural network model, different layers, as we've talked about, max pooling, etc., etc. We trained it, so it starts off being quite low, and then you start doing sort of other things that I listed, things like data augmentation, randomly shift things. So we're training here from scratch, randomly shift things. I try the thing with the data augmentation, hardly any improvement, slight. Then you do some transfer learning. You had did some transfer learning on this. Tried a couple of other things. Got some things from TF Hub, etc. Anyway, you do a bunch of work and you come up with maybe 60, 80% after going through this step. So if you want to go through all the sort of different steps with this, you can look at that notebook. The one we're looking at is slightly simpler. So things are being made slightly simpler with Model Maker. So with Model Maker, here the model, instead of creating a whole model, we're going to use one line to build a model. And you call image classifier create, it creates an image classifier. And because Model Maker was made for maybe mobile devices, so devices in the low end of compute, you fine tunes a base model. And here the default model is EfficientNet. So EfficientNet is one type of model, but you also have MobileNet. So these are small models that have been built, small in size, that can be leveraged for things like a mobile phone. So when you call this image classifier create without any other parameters, then you have, it calls EfficientNet model, takes your data, your training data, and then fine tunes your data based off of that EfficientNet. So you can see it does everything. You can print your model, your trained model, and you can see these are the accuracies of the training. So it quickly improves the training compared to, for example, how we're trying to build our own models previously. Quickly get some accurate, and this is just with 5 epochs. But in your lab, you can extend these, improve the epochs by by augmenting this, adding more parameters here. All right, so this is our model, simple model. You just have a base efficient net extractor for representations, and you have some dropout, and then you have our dense layer, which is our output layer with 5 classes. So it returns a 5 classes, a vector of 5, each representing any one of the classes of the 5 of the diseases that we're interested in. All right, so you can also evaluate the model very simply with the test data. So we see we're getting already 85%. So I expect you guys, when you do it in the lab, that you get more than 85%. This was just one run with 5 epochs. And then you can sort of predict, you can, this helper function, if you add a trained model to the test data, it gives you an idea of how well your model is doing. So for each leaf, it shows you the prediction and the true class. And you can see for our model here, for these images, and where it's red is the images where it failed. So you see predicted CGM when it's CBSD, predicted CBB when CMD. But overall, it sort of does quite well for the few lines of code we've done here. So things have been improved quite well over time. All right, so we've trained something. So is it robust? So that's one way to ask, is our model robust? So if we exported this model here, the way it is, give it to a farmer, export it, put it on a mobile phone, give it to a farmer, would they get the benefits from the model? So we try that. So unfortunately, when you do that, from my experience in deploying these models, the farmer is going to immediately get the thing and point at a desk or at a chicken or at a cow and see what the thing does. So if we do the same thing, so in this case, we downloaded a flowers data set we just downloaded it from this link, downloaded it, loaded it into our flower data, etc. And then we tried our model on it, right? So when we try our model on this data set, what do we get? So we get everything wrong, of course. But you can see what it's doing, it's predicting disease for each of these images, right? CMD, for a house, it predicted CMD. So if a farmer points at a cow, your model will come up with something like healthy or disease CMD, and normally this quickly frustrates the farmer because one, even if they're using the model, the app badly, they're pointing it at cows instead of plants, it's giving them something weird. So they lose a bit of trust in the model. But also because when you point it at a plant and it comes up with CMD, you're not entirely sure whether is it CMD, is it extracting the right features, or is it doing some sort of random guess like here? There are certain things it's doing that are not related to the disease. And so you want to add another class. You want to add an unknown class, basically, especially for apps you need to deploy, so that you want the model, when you point it at a window, it says unknown. When you point it at a bean plant instead of a cassava plant, you want it to say unknown. You don't want it to say that the bean has cassava mosaic disease. So you need to add an unknown class. That's one way of making it more robust. So this adding the unknown class, I left as your assignment, but I've left you many resources to be able to do that. But I wanted to pull out so there's a CropNet model which was built on a larger data set of cassava plants, across 1 million images, and this is on TF Hub. So TF Hub is where you can share these models. So you can download it. I put a So this link here is basically, you can use it to download the model, and you do some pre-processing. So the pre-processing basically is to take your image and format it to the format that is agreeable to the model that you've downloaded, right? So models have different input sizes, and so these are really simple pre-processing things. Normalize the image, resize it, and then for flowers, it's slightly different because you want to normalize, resize, but you also want to assign them a class 5 for unknown, right? So that the model can predict unknown. So this model here, the CropNet model, is similar to the model you've built, but it's more robust because it has an unknown class built from a large data set of unknown, of flowers, trees, etc. So we try it with our data. So if we try that model downloaded with our test data, we get up to 94%. So with our model that we trained, we got something like 85. But this is without doing anything, right? We hardly did anything. But I expect that you guys in the practical lab, that you tweak this a bit, change the learning rate, change the model you're building on, etc. And maybe come close to this performance of 94, right? Because this was built from scratch. The collabs are a link below how it was trained. All right, and when you run the performance on, for example, on the flower data set, so ideally it should return unknown, unknown. And we can see the accuracy here is actually 1, which means it's fairly robust for things like flowers, that it knows that these are all unknown. So this is really what I wanted to show, that you can, once you build it, add some robustness to the model, then now it's at a point where you can deploy it, for example, this one here, because if a farmer points hopefully at a flower, it says unknown. Hopefully at a window, it says unknown. But to cassava crops, it provides the disease diagnostics. Right, and then you can export it to a TF Lite model or any other sort of format you want. There are several formats you can. And you can use that in an Android app to quickly deploy it. Right. So your assignment in the lab, maybe what you can do right now and possibly in the afternoon, is you can try some of these things from basic to intermediate. And I provide some links in this tutorial where you can. So for example, this is a CropNet model. This is how to use it to diagnose disease if you have cassava. I provide this link there, so you can, it's a collab, so you can sort of see how it was done. And then how it was trained, how this big CropNet model was trained. There's also a collab, again, uses Model Maker. So you can also use this to add a, for example, adding unknown data sets. You can see how we used ImageNet, used flowers, the flowers we've been using, used the beans, all those images to build an unknown class. Added it to the cassava data set and trained it. Apply augmentations, if you want to apply augmentations, change the data bit, etc. And train it. Again, you can use different base models here. There are different types of base models you can sort of look at, and you can click on them and go to the actual TF Hub site and see what the model is, what data it takes, the size of the image input, etc. You can change the image, the spec, learning rate, epochs, etc. So all this is linked to this collab. Right. So that's basically the end of the the presentation and the collab. So your role, if you so wish to do this assignment, first go through this collab and then try the assignments. The best thing you could do is, if you have your own data set, try and do a similar thing with your own data set. If you have a data set, particularly for crop disease detection or something like that, is to try this. And then that should give you an interesting result. Cool. So yeah, just to recap, so the major goal of this LISA computer vision section is really to look at practical ways of solving this problem and some of the tools that are available now to do it. So yeah, and I think, as you can see, there are really simple steps to try and start building your own model.
Sir?
Sorry?
Pardon, Mr. Ernest, there are a few concerns from the participants concerning the time when they were running the code.
Oh, okay.
Yes,
Sorry,
sir.
I'm seeing them now. Right. All right, let's try and sort that out. Okay, so has anyone managed to download the data? Has anyone managed to run step 5 successfully? This one here, load the data. Okay, so someone managed. Right, module not installed. Yeah, so you need to run these commands here. You need to have all the inputs running. So make sure that number 3 has run successfully if the inputs are not running. So that should solve the module error. Looks like you may not have data loader loaded. Okay, what other issues? Oh, wait, okay. Has anyone run the whole collab successfully? Maybe that should be the first. So for example, if you click run time and click run all, it should run everything. I don't know if someone has gone to cell by cell. Has someone managed to run everything without errors? Hello? Okay, still running cells and flowers. Okay, all right, cool. All right, so, okay, let's see which problems then people are facing. Any other? Okay, looks like most problems. Anyone still with a problem that is not solved? Maybe you can put it in the chat since we have 1 minute remaining. Yeah, so Safiso, which error, which same error? Which module is not found from the error? So Sifisu, in the error code, in the error message, does it name the module that's not found? And which cell is that? Cell 7. This one, load data. Is this one, load data from GitHub repo? Yeah, so the only module here is the data loader. That's the only thing here. So you have to make sure that this was run, this line here, that this was run and it didn't return an error. Okay, we are 2 minutes over. Okay, so here's my suggestion. I think we'll go for break. Let's try and troubleshoot. Yeah, but this module name is not there. DSA 2019 CV is not the one we are running. We are running DSA 2020 CV. Please look at the notebook. I don't know whether you changed it or not. So yeah, so guys, just look at this. Go through the notebook. Maybe we can look at it after the break. So the name predicts is not defined. Let me see. Which module is that?
Ernest, can I jump in a little?
Yes.
Is it possible also that you'll all be available in the afternoon?
Yes, I'll be available. Yeah.
Yeah. So in that case, maybe what can happen is that participants can attempt to go through some of the cells. I know there's not a lot of time between the breaks, but also during that time, there'll be a special room where you can talk to Ernest directly if there are certain issues there. Help more with the troubleshooting, so that we can take the break and then come back because things move quite fast in DSA. We are already now in the third session with visualization. Thanks.
Right. Thanks a lot, Shreya. Thanks, guys. Let's catch up in the afternoon. But troubleshooting is one of the skills of machine learning. So please take some time to troubleshoot. The errors are normally in English, so you can try and follow them. Thanks a lot, people.
I think maybe did you insert any intentional errors? And then maybe there's a prize.
That's the training.
There's a prize for the person who gets it all to work. But yeah, so that's, as Ernest says, it's quite a skill going through code and things, but we'll be there to help in the afternoon.
Indeed. Thanks a lot, people. Bye.
So there's a break until, so Hannah, are you going to tell people about the break? And maybe a few things about your university as they wait.
Pardon, sir?
I was saying, so we are on a break now, so people can grab a coffee or anything, but maybe in the meantime, you can tell them something about your university if you'd like to. We can simulate as closely as possible a real DSA physical event where people can chat. And also remember, you're free to raise your hand and unmute and speak also. So we can also hear a few questions, maybe some comments. Hannah, over to you.
Okay, so. Okay, good morning, everyone. I am Hannah Sibolai, and I'm part of the data science, the Salt Lake University team that's part of this event. So, and I'm also studying, I'm in my second year of data science at Salt Lake University. And maybe just for starters, maybe for starters, you can just maybe comment in the section how the weather is from your side. Yeah, even from my side, it's very it's hot. So anyway, can anyone just perhaps unmute themselves and speak on the experience so far attending the session, if maybe perhaps it's the first time or if they're returning, how the experience has been on the first day? I see someone from Zambia. I would like to say Mulibwanji. I don't know if that was correct or not. Can participant Ulumanda confirm if my greeting was correct or not? Yeah, I'm kind of rusty.
You actually did try. I think we'll give you F for effort, but other than the pronunciation, it was correct. Mulibwanji.
Oh, okay. Thank you so much. Because like my family went to Zambia during the apartheid era, so because of that, I can understand the language, but every time I have to speak it, they always laugh at me. So yeah, I try.
But do you know what it's called? The
Uh,
greeting. Do you know from which language you got it from?
Chinyanja. Is that right?
Okay, yeah, it is. There we go.
Is there anyone else who would perhaps like to share greeting in their language if they come from like another part of Africa? or someone from Joburg per se can just share maybe a greeting in like a different African language or a different language within South Africa.
Has anyone from Kenya contributed? Sorry, I stepped out a little bit. With a greeting. So we would say habari zenu from Kenya.
Okay. At least I'm hoping that when this week ends, I'll know one or two things to say from other languages, so that at least when I travel to those languages, I don't hit a brick wall. Like saying a greeting in the natives' language is an easier way to pave communication and to maybe get help or information that you might need in the country. So getting help with those greetings would really go a long way. Thank you, sir.
Okay. Are we 2 minutes to the next session? So that break has gone really fast.
Yes, it has. I hope people have made tea and just managed to get a good stretch before they can come back and proceed with the sessions to follow.
Great. So I think Claire, Deep, David are on. So I think we'll be able to hear from them. And greetings to our participant from Tunisia. It's always great to know that we are represented north, south, east, west, everything the figure. Okay, I think we can get Claire and the team. Deep, I saw you on the participant list.
Hi, Shia. Yes, we are here. I've seen Claire. I haven't looked at everyone here. So how would you like us to start? Do we need to share our videos, or is it okay just sharing the screen?
Just, you can feel free, share your screen. And if you want to say hello with your video on, you can do that. Feel free to do whatever makes you comfortable.
Okay, I'll just quickly share my video. Hi everyone, great to be here. And I can get on with the slides. So I'll just share my slides as well. I hope everyone can hear me.
Yes, we can.
Okay, that's great. Welcome to this session. We will be talking about data visualization. And hopefully, all of you will have experienced data visualization in some way or the other. So my name is Shubhadeep Mazumdar. You can call me Deep. And we have Claire and Hewitt with us as well over here. And before we get started, we'll do a very quick introduction just about ourselves. So it'll be a good idea for us to share our research and what we do. So I'm a lecturer in data analytics, big data, information visualization, and social media research in the University of Sheffield. And my research explores developing techniques and mechanisms for reducing the barrier for user communities to understand large complex data. So on the right, we have an image illustrating that we have very complex data sets. And what I try to do is make use of techniques like big data analytics, data visualization, human-computer interaction to work with stakeholders so that they can understand the complex data sets that they work with. And over here, stakeholders are not just people who work with the large-scale data sets, but also people who are ordinary members of the public. They are also people who are based in communities. So I work with a range of people from different areas of expertise to make large-scale data more accessible. And I also work with user communities, with general members of the community to help them enrich large volumes of complex data. So I use techniques like crowdsourcing, citizen science, and human-computer interaction to make allow people to contribute to large-scale data sets. So I'll quickly pass on to Claire. Claire, if you're there, can you please talk about yourself and your research?
Thank you, Deep. Good morning, good afternoon, everyone. We are glad to have you here. My name is Claire Babidia. I am a research assistant at the Makerere Artificial Intelligence Lab. And my work is in the areas of data science, natural language processing for low resource languages, and computer vision. So the quote below there is just around visualization, since today we shall be talking about visualization. And it goes by, there is a magic in graphs. The profile of a curve reveals in a flash a whole situation. It could be a life history of an epidemic, it could be a panic, or it could be an era of prosperity. So the curve informs the mind, it awakens the imagination. In other words, it convinces, and that is by Henry Hubbard. Thank you, Dick.
That's great. Thank you, Claire. That's a great inspirational statement there. Thanks for sharing that. We have also Hubert. Hubert, would you like to share what we've got there?
Good afternoon, everyone. My name is Hewitt Tisime. I am a final year student of a Bachelor of Science in Software Engineering here at Makerere University. I'm also a research assistant at the Makerere AI Lab. I have worked on different projects in data science and machine learning, data science for business analytics. I've also done data science on social media data. I am currently working on a self-help application for using speech recognition for mental health as my final year project. And yeah, my quote is by Stephen Few, who says numbers have an important story to tell, but they rely on all of us to give them a clear and convincing voice. Yeah.
That's great. Thank you, Hewitt. Well, one thing that it's quite clear that visualizations are not just charting data, but they have a wider implication. And hopefully with this initial presentation, you get a sense of why we are saying that. So let's move on. This lecture aims to introduce the notion of information visualization. So this will be a very quick session right in the beginning where we talk about the theoretical aspects of data visualization. And by the end of the lecture, you should be able to describe notion of information visualizations, recognize why we need to visualize data and what are the benefits of that, and also some typical processes that are involved in creating the visualizations. And we will have a hands-on session right after. So I aim to quickly finish my part so that we can go into the more exciting bit of the practicals. And this will be to practice different information visualization techniques. So we wanted to talk a bit around what the context of data visualization is. So you might have come across these terms: data, information, knowledge, and so on. So data, once we contextualize data a bit, we use a bit of transformation, that becomes information. And we take the information, we apply some reasoning, we apply some analysis, interpretation, and that becomes knowledge. And the knowledge can be expressed by information, and information can be decontextualized to become data. So this is like a knowledge cycle. And this is quite common in these kind of processes, and these kind of theoretical approaches are quite common in knowledge management. So what we want to do is to take data, transform it to knowledge, and from that knowledge, we can take insight and we can take actions. And in this process, we make use of data visualization as one of the techniques where we take the information and we try to understand it and gain some insights, and we use data visualization to gain these insights. Now, data visualization is not just charts. They can be visual representations of information as well. So for example, we can use visual metaphors and we can use different types of ways of expressing what are the different types of coffees. And over here is a really nice example of using visual metaphors to explain what the different types of coffees are. We also come across really interesting and creative ways of applying data visualization. And this was an example from many years back, and Michael Najar looked at the pictures of the Alps. And what they did was adapt these pictures to show variations in stock market prices. So it's not just making the chart, but it's also making it in a way that can be quite exciting and quite creative. Now, if you also look at a lot of other examples, so if we just plot earthquake events and using things like just plotting them on the exact location we've come across these events, that might help us understand how the tectonic plates are arranged and how these arrangements lead to earthquake events. Speaking of earthquakes, we can also use data visualization to understand how large-scale events happen, and we can take data from a lot of different sources. So one of these examples is a really nice example of talking about big data and what we can do with big data. So we all wear these kind of bands where we collect activity data. So around, I think it was around 2014 that there was an earthquake. And what Jawbone could do, and at that time Jawbone was quite well used within the US. So what they did was they took the activity patterns and they could see that there was a spike in the activity pattern at around just after 3 a.m. And this spike was because there was an earthquake and people got up from that earthquake and suddenly their activities started going up. And looking at this spike, you can also map out using a different form of data visualization, which is a geographical map. You could map out where the earthquake event happened. So the Napa Valley, which is the blue dot on the right, that's where that was very close to the epicenter of the earthquake. And at the same time, there was the activity pattern in other cities. And because of the activity levels, they could infer where the epicenter was. So another example of making use of data visualization to do some analytical tasks. And there are lots of different visualizations we come across. So you can see things like pie charts, bar charts. You can see more complex data visualizations like a spider chart on the bottom, or even one of the classical examples, which is the London Underground map. It's a really good example of how a nice data visualization can be created. So data visualization is something which can represent information and help us understand aspects of data. But what we also need is data analysis. So we don't just plot the data, we do some analysis on the data. And in the previous sessions and in the next few days, you will come across lots of methods how we can model data, how we can learn from data. And typically what we do is we take the data, we visualize it, we create models, and this is a cyclic process. And while we do this, we create models, we improve our models based on what we visualize. And while we do this, we eventually help improve our knowledge on a particular topic. So hopefully you will get to experience quite a lot of the modeling and quite a lot of visualization as you progress in the next few days. So what is data visualization? It is a graphical display of abstract information for sense making and communication. And there are lots of different kind of descriptions and illustrations of what data visualization is. But essentially, data visualization has different aspects like representation, presentation, visual perception abilities that we use to understand and to enhance our understanding about a particular topic. And why do we need to visualize? It's useful in both organizing and making sense of data, particularly when we have a lot of data visualization. And data visualization gives you answers to questions you didn't even know you had. So once you visualize the data, that's when you might have more questions. So it eventually helps us get more insights, make the invisible aspect of the data visible. And that's quite interesting because we've got an example. So numbers alone do not tell the story. So for example, and this is quite classical example in data visualization, it's called Anscombe's quartet. And this is, these are just numbers, but the way you read these numbers are on the leftmost two columns, they are the X and Y values of one data set. The one next to it is another data set. So we have 4 data sets with quite different X and Y values. So you might not be able to, well, you might actually be able to see quite a lot of differences across these data sets. And when you look at the statistical aspects of these 4 data sets, if you look at mean values or the sample variance or the mean of Y, correlation, linear regression, all of the data sets have the same values. However, once you look at them plotted out, that's when you see that these 4 example data sets are completely different. So just by doing statistical analysis, you may not always be able to understand what the data is like. Statistical values help us understand from a broader perspective what data is. But once you visualize in different facets, that's when you understand how the data looks like. And there are lots of ways we can create these data visualizations. So Ben Fry proposed this model where you have 7 stages of visualizing data. So first you acquire the data, you parse it, you make some modifications on the data, you filter it, remove all of the unnecessary data, you mine it, and then you represent, refine, and then interact with it. And in this process of data visualization, you'll realize that only the last 3 stages are actually about building the chart or creating your plot. There's quite a few other stages that you need to do in order to create your visualization. And Simon Rogers from The Guardian has this really nice quote. They say that data visualization is 80% perspiration, which is all the hard work you have to make data sets more visualizable. It's 10% of it is great idea, and only 10% of it is actually the visualization. Bill Furster also proposed another framework, which was a search framework, which is a very popular framework to create visualizations. Where you first start with asking a question, then you search for information, you structure the data, you modify the different fields, you envision the answer, then you represent the visualization, and that visualization helps you tell the story. So again, at the last stages, that's where you are actually plotting the data or creating the visualizations. And there are loads of really good examples of charts. For example, Google Charts has quite a lot of different ways of visualizing data. D3 has a lot of really good examples, workable solutions as well, if you want to create something quite dynamic. And the question is, you can use a lot of different frameworks to choose the right data visualization approach. And we will not go into that in this section, but I will point you to some resources that can help you. One of the ways we can decide which visualization is useful is through this chart. And in this chart, what you start off with is, what would you like to show? If you want to show a distribution, then you follow the ones on the right. If you want to compare different variables, or if you want to compare different factors, then you use what's on the top. If you want to show the relationship between 2 variables, you use the one on the left. So there are different ways you can choose which visualization you might be using. So what we've got now, it's a very quick task, and we will only spend 2 minutes, and then we'll move on to the practical bit. There is one slide right after this, where we have an example from the real world. I'd like you to look at the at the example and write down any issues that you can find with that visualization. So here is the visualization, and it's about internet penetration per 1,000 inhabitants in the African nations. This is something from 2012, and this is a real life example of how data visualization is used. Now, what I'd like you to do is take 10 seconds, 15 seconds, and just write on the chat if you can spot any mistakes or if you can spot anything which is wrong or which doesn't make sense. So we'll give it about 30 seconds or a minute at the most. Okay, I see some answers coming in. Anvit, you mentioned color scale. That's a really good point. Absolutely right. There is something going on with the color scale. Generally, when we look at these kind of charts or these kind of maps, we tend to use something like a color map, and which is actually a gradient. So that helps us understand just by looking at the color, if it's a higher value or if it's a lower value. Now, what you have in this color scale are just random colors. And when you have random colors on a map, it makes it really difficult to understand any patterns in the data. And again, there are things like when you have countries which are very close to each other, you need to find some way of making the differences highlighted a lot more. There is no pattern to these color scales. And that's a big problem. So when you're designing visualizations, be careful about how you use the color scales. Janice, you say that the names of the countries are not clear. They don't have a key. That's absolutely right again. There are loads of problems with this chart. And that what you say is one of these problems. You don't know that you don't have a key. So if you're not very familiar with the names of countries or the codes that they've used, you're going to struggle with this. So really good example of how not to design visualizations and what are the things that you should be careful of when you're creating visualization. So with this, I think what we'll do is we'll do a very quick wrap up of the theoretical part. And I'd like to wrap up with this quote right at the bottom. There is a strand of the data visualization world that argues that everything could be a bar chart. That's possibly true, but it's also a world without joy. You use data visualization not just to plot data, but also to tell a story. And there is a wider aspect of communication that data visualization hopes to fulfill. So we move on to the lab session, and I will invite Claire and Hewitt to join us and lead on the lab component. So Claire and Hewitt, over to you.
Thank you, Dr. Deep. Just share my screen and then we can go on with the lab session. Okay, I think let's Okay, I'll jump right into it. So like I had mentioned earlier, my name is Hewitt Tusime, and Claire and I will be taking you through this session. So I'll handle the basics on how to create basic visualizations, and then Claire will take us through a sample data set on COVID-19, and then we can have some real life example on what visualizations look like. Yes. So for every installation that we do of Anaconda, to get Jupyter Notebook, Matplotlib and Seaborn are some of the packages that come with it to aid us with data visualizations. So Matplotlib is an excellent 2D and 3D graphics library for generating scientific figures. So those are the pros of Matplotlib. And also, just in case you do not have it installed, you can either use Conda or pip to install it. Yeah, so using the syntax above. So I guess I'll just jump into it. After
if I may, excuse me, sorry to interrupt you. I just want to ask in the chat if people could type if they are able to run the notebook, if the link is working fine, so that they are moving along with you. Right. Can we get some messages in the chat to confirm that you're able to run the notebook?
I think they have confirmed. I don't know if you can see it.
Okay, perfect. So go ahead. Please go ahead.
Right, yes. So I was, as I was saying, you have to first, import it. Import Matplotlib and Seaborn. We shall import Seaborn just below when we start working with Seaborn to make the visualizations. So like you see, I imported matplotlib.pyplot as PLT, and I just created dummy data using linspace, using pandas. Using NumPy rather. Using linspace to just create numbers between the range of 0 to 5 and 11 digits, just to explore or to share with you the basic visualizations that we can start with. So just using the ordinary plot to see how the different values of X and Y correlate or behave. I guess we have people interacting with the notebook, so we shall have a few hiccups with it. Okay. Yeah. So you can see the values up there. So just to plot how they relate, or just create a basic plot, if you have, say, a variable of X and Y, you can just use plt.plot. Remember, we're still using matplotlib to plot the different values, and then set the X label and the Y label, and also give your visualization a title. And so we also use plt.show to make sure that the visualization appears. Yes.
Is it me, or did we just lose Hewitt?
I think we probably lost Hewitt. Claire, are you there?
Claire?
Claire doesn't seem to be in the list of people over here. So I think we lost Claire as well as.
Must be an internet problem. Yeah.
Yeah,
must be
it
an
looks
internet
like that.
problem.
Okay, so maybe until they join us, I can probably talk through some of this if that is okay.
Yeah, or we could even have some questions if there was anyone who had questions for you.
Sorry about that. We have internet issues.
No worries. You're welcome back.
Oh, that's great. I'll stop the sharing then.
Okay. Go ahead and share. Hewitt.
Yes, I'm working on it.
Okay, so someone is asking in the chat, when we load the link, what next? Maybe Hewitt, you will attend to that as you get started.
Okay, so once you load the link, you can just follow through. We shall share the sample data set as well for Claire's presentation, because that's a data set that you might need to run the example below, the example down. But yeah, we're just using random data. Yeah, so as I was saying, for the subplot, you specify the number of rows you want, the number of columns. It takes on the number of rows, the number of columns, and the plot number. So here we specified that we want 2 rows, but in 1 column. And we specify that so you specify, sorry about that, someone had lost us. You specify which plot is plot 1 and which plot is plot 2. So as you see, let's just use the color code to tell the difference of the graphs. So the one with red is what I specified as plot 1, and the one with a color code green is what I specified to appear as plot 2. So you can just play around with this. If say you want them to appear as 2 different columns, so subplots help us utilize the graph space or the image space, yeah, to have multiple graphs in one image. So yeah, you can use that in matplotlib. Yeah, and then matplot as an object-oriented method, yeah. So we can still use the matplot object-oriented API to instantiate figure objects and then call methods or attributes from that object. So here we first instantiate a figure object called fig, yes? And then we can specify the kind of axis or what we want our figure to appear as, yes? So we want it 0.1 to the left, 0.1 bottom, 0.8 as the width is, and 0.8 as the height, yes? So still using our random data, which is X and Y, and the color coding. We have very many multiple color codes, so you can use any of your choice. As blue, we set the X label and the Y label. These are just naming of the axis, yes? And we set the title. So this is what your image will appear as, yes? So this is just all about defining what or customizing what you want your visualization to appear as. Yeah, forgive me if I'm too fast. I just want to have enough time for Claire to take us through the real life example. Yes, and then, so yeah, here we say that code is a little more complicated, but the advantage is that you have full control of what your axis should look like, yes? So still looking at the example above where we instantiate an object, fig. So here we just specify, and we want just like the way we were using the subplot above, but this one, we can have an image, a graph inside another graph. So if we use matplot as an object-oriented API, yes, we can have 2 graphs in the same image. I don't know if you get what I'm saying, but just like you see, we have the bigger graph and the lower graph. So you just specify that this access to should have smaller dimensions, or what we define as the parameters for the axis compared to axis 1, but in the same figure object. Yeah, so you can also specify the figure size, the aspect ratio, the dots per inch. These are all just things that can help you customize your visualization. Yeah, we also included something on how you can save your visualizations. Yeah, just in case you want to include them in like a presentation or something like that. You can just, this was the figure object, yes? So if your visualization was called fig, you can just use the .save fig and save your image as a PNG, as a JPG, and all those other formats that you may want. Yes, another important aspect that you can add to your visualization may be a legend. So just to help the people looking at your visualization understand, okay, what does the blue line mean? What does the green line mean? Or what does it stand for? You can add an axis, a legend rather, to your plot. And yeah, so you just use the AX dot to add a legend to your visualization. So you can also use the lock keyword argument, yes, in the legend method to specify where you want your legend to appear. Yeah, so this one takes on, since I specified very many, it takes on the very last one, which is the lower right corner, which is ax.legend lock equals to 4. So the different corners or sides of where you can put the legend are denoted by numbers. So lock is equals to 1 is for the upper right corner, lock is equals to 2 is for the upper left corner, and so on and so forth. Yeah. So moving on still to the distribution plot. So we can have a dis plot, a joint plot, and a pair plot. And to just explain this, we shall use Seaborn. So Seaborn is a Python data visualization library based on matplotlib. So Seaborn basically adds the aesthetics to the visualizations that matplotlib does not. Yes. So just like we said there, it provides a high-level interface for drawing attractive visualizations. Its dataset-oriented plotting functions operate on data frames and arrays containing whole datasets, and internally perform the necessary semantic mapping. Yeah, and so on. So just like we did for matplotlib, we also import Seaborn. Oh, and I think to best visualize this, we used a dataset from a diner or a restaurant, what we'd call a restaurant here in Uganda. And yeah, so we just load the data set. So the data has the different columns, like the total bill paid by that person, the amount of tip they gave to the waiter, the sex, are they a smoker or not, what time of the day did they visit the restaurant, time to also reflect the meal they took. Was it dinner? Was it lunch? Was it brunch? And then the size. It's also denote how many meals that person had. So just look at the distribution plot. So the SNS is the Seaborn. I imported Seaborn as in SNS. So the dis plot gives us, it can help us visualize univariate variable. So if we look at total bill, it helps us see its distribution in our data set. So we see that very many people paid between 10 to 20 USDs for a particular meal. And like we said, if what we use the visualizations for is to help us understand our data, so that in case we are running a machine learning model on that data, we know how the different variables or columns in our data are related just by looking at the visualizations that you create while you explore your data before you do the actual machine learning. So this gives us a picture of what total bill looks like in our data, or how much people are willing to pay for meals in that restaurant. And the joint plot allows us visualize more than one variable in our data. And here we look at total bill and tip. And we're just trying to see, is there a relation between total bill and tip? Is someone who pays more willing to give a higher tip? Or is it actually the people that buy less that actually tip these waitresses? And it just helps give us a correlation between the total bill and the tip. And as you see, the people that actually pay more for their meal also give high tips. Yes, so maybe we can call these people the rich people that that visit the restaurant. I don't know. Yeah. Here we'll just add. So as you see, we combine the scatter and the bar graphs, and you see that this information actually correlates. You see that the bar graphs correlate with the scatter plot on the different variables that we look at. And then just to look at the pair plot, it provides a pairwise relationship for all your data. Say if we want to look at our whole data and how the different columns or data variables relate to each other, we can use a pair plot. So just looking at total bill, tip, and size and how they all correlate, we can use a pair plot. I think we shall see this below better in the other examples. So just to make this also a bit more interesting, we added hue and to see how this categorical data on sex actually differs for the different columns, and looking at how the males and the females behave in the diner. Yeah, I think we can look at just total bill. So looking at total bill and total bill still, we see that the males are willing to pay more than the females. So you just look at the different pairs and then draw insights from them. So for categorical data, we can look at factor plots, box plots, violin plots, strip plots, swarm plots, yeah, and the like. So looking at the bar plot and the count plot, I think someone in the morning had already shared this in the explorative data analysis. Yes, so if we look at a bar plot on sex and total bill, so you see that still, just like we mentioned up there in the pair plot, the males, it's evident that the males paid higher bills than the females. If we look at just a count plot, there are more males in the data set compared to the females. Yep. So looking at the box plot as well, so they help us show a distribution of categorical data. Yes. So just like you see here, it's just here the first box plot is on day and total bill, but this doesn't exactly give us a very good representation. But if we look at the categorical data on who is a smoker and who is not a smoker, I think this can also help us understand our data better. So you just add a hue on smoker. So you see yes and no. So more people smoke on Sunday. But then if you look at the distribution for those that do not smoke on Saturday, is much more higher than, much more spread than those who smoke on Sunday. Yeah, so the box plot just gives you an understanding of the different quartiles, yes, that are represented in your data based on the two variables that you look at. So the strip plot will draw, moving forward to the strip plot, it will draw a scatter plot where one variable is categorical. So a strip plot can be drawn on its own, but it is good as a complement to a box or a violin plot. So we didn't share violin plots, but I think in your free time or as an extension of your take-home exercise, I think you can also look at the violin plots. They're quite interesting. So looking at a strip plot on a day and total bill, yeah. So it takes on the y-axis, the x-axis, as well as your data being tips. If we look at it, you see that there, as in it helps us tell or see the distribution of the total bill on the different days. Yes, so it shows you how much more is earned on the different days. But if we add something on the 6, it also gives us, sorry, let me just make sure that you're viewing what I'm viewing. Okay, sorry about that. Okay, I'm about to conclude so that we can move on to the COVID-19 example. Okay, I guess the notebook has been okay, yeah. So here we are. So we're looking at a strip plot of how the 6 is distributed across day and total bill. So still, it also gives us an understanding of how females or males behave on the different days. And I think the concentration of the data points can help you understand how much more is spent on a particular day by a particular sex or group of people. So of course, the people looking at this data, or like say the people in the diner, can maybe plan for the different people that visit their diner on a particular day. Okay, let's just look at matrix plots, then I can finish. Okay, so still looking at the tips data set, then matrix plots helps us plot data as color encoded matrices. So we would need to first get a correlation between the different variables, say total bill, tip, and size, and then we can plot that, and it can help us tell what is dependent on what and what is not dependent on the other. So looking at this heat map from the correlation matrix between the different variables. So an interesting bit would be size and tip. So we can see that the size of the meal does not in any way, or it doesn't affect the tip given to the waitress that much as compared to the tip and the total bill paid for the meal. So you see the correlation is 0.6 for between tip and total bill, but the correlation between size and tip is less. So just to give people a better understanding of how these things correlate, it's usually difficult for them to understand that table, but if you share a heat map like this with a scale, I think it can help them understand your correlation better. Yeah, I think I can hand over to Claire. Thank you for listening.
Okay, thank you, Dr. Deep. Thank you, Hewitt. I think I'll get right into it. Can I share my screen? All right, I hope everyone can see my screen. So I will be taking you through one of the data sets that we came across, and this is a coronavirus data set that was collected from 2020 to August 2021. And we shall be seeing the details within this data set. So, so first of all, we are using Colab, and reasons being, when it comes to Colab, you don't really need to install the different packages that you need to be able to follow through with us or to run the notebook. But in case you're running this on your local host, you'll find that you'll have to make the different installations that have been mentioned. Okay, and then so on this side of the screen where my cursor is hovering, I have the files that I need. First of all, I have the CSV file itself. So Dr. Dina in the morning showed us how we can be able to mount our Google Drive and then be able to upload the data. But then the other way would be to minimize the screen where the data is coming from, and then you just drop it here under files. So when you do that dropping, then you should be able to do the pd.read CSV. Otherwise, you'll have to do it the way Dr. Dina mentioned much earlier. So the first thing that I do here is I read the data into this working space, which is Colab, because it's an external file that I'm working with. And it's a CSV file, that's why I'm using the read CSV method. Then like how it's indicated, we already imported pandas, but we imported it as an alias name PD, meaning every time we want to use it, we refer to it using this alias name. So once we've done the importing, then maybe the first thing that we could investigate is the shape of the data. So the shape is a matrix that carries two values, which is row by column. And so this means that in this particular data set, we have 159,030 data points and 9 columns. So this is important, especially when you want to explore your data. I think Dr. Nema tried to indicate this. She actually indicated this. She did not try, sorry. She indicated this, that when you're going to do predictive analysis, you want to find out the size of the data. So if you run a dot shape, it first of all gives you the number of records in the data, and then you can carry out more explorations that will lead you into predictive analysis. So that is the idea of the dot shape. Then right here in the next cell, what we did was we dropped missing values. So the team still indicated how to deal with missing values. You can either choose to drop them, you can choose to fill them, and so on and so forth. So for this case, we noticed, this is something that had to go a little bit down maybe. So for this case, we noticed that we had entries where we did not have values under latitude and longitude. But maybe before I go into that, let me just add a cell here where I return the columns so that we know where latitude and longitude, these variables are coming from. So the dot columns helps us to know the names of the columns. Much as here with dot shape, we return the number of columns, the dot column method helps us to know what are the columns. So in this case, the columns that were captured while collecting this data include state, country, lat and long for latitude and longitude, date, confirmed, date, recovered, and active. And with this, you can know that given the fact that we have latitude and longitude, this is already geospatial data. So we can choose to do visualizations in regards to mapping the data, because I guess that would be the best visualization for geocoded data. Then you can also see that we have dates, and we are going to see how the date was captured. But the fact that we have date, this means that this is temporal data. So we can choose to run an analysis over time and then see maybe in this particular country, how many confirmed cases did they have? How many death cases did they have? How many recovered cases did they have? Because like Dr. Deep indicated, there is a story to tell and you're trying to pull the insights from the data because especially for COVID, we've seen the governments have come in to put up different mitigation strategies from lockdown to restrictions, to different restrictions. And now we are seeing vaccinations, etc. So you would really want to see what is the effect of this? What is the effect of lockdown? If Uganda was in lockdown in July, how many confirmed cases did we have at the end of July? Things like that. Things like that. So that is the whole point of visualization. So anyway, I was still explaining that here we chose to drop the records that did not have values under latitude and longitude. So latitude and longitude, like we've seen, these are columns within the data. And drop now is a method that drops missing values. In other words, values that are recorded as NaN, none. So a subset is because we are capturing a particular we are sort of like filtering this drop now, not to be affected on the entire data set, but we want it to be affected following these two columns. Otherwise, if we don't make those specifications, it means that it's going to drop all missing values. So if I have an entry without a date, it will be dropped. If I have an entry without death cases, it will be dropped, something like that. And then for the in place, we want to effect this on the data set itself. So that's why we are setting this argument in place to a value called true. Okay, then so dot shape, we've already seen that. Then dot head is a method that helps us to return a portion of our data, but this helps us to return the first 5 values in case we do not mention a value here. So if we want to return 5 by default, head returns the first 5. But if we want to return more than 5, then we specify the values that we want to return. We could also return a value that is less than 5. So if we want to return 2, we make that specification. But yeah, these are the values that have been returned. Sorry, that's the portion of the data that has been returned. And then, okay, I think, so try not to edit the code because I think we have very many people in the code. Sean, but moving on. Okay, so then there is a method called unique, yeah, because there are cases where you have duplicate entries. For example, for our case, this is data that was recorded over time. And let me just do this, I guess. Yeah, but okay, yeah, so this is data that was recorded over time. For example, here we can see that 8 and 9, these are different values. These are different values for Australia, and basically they differ in terms of state, yeah? But in terms of the number of entries that I have in the data, it's counting all the number of entries. So if I want to know the number of unique entries that I have, I can go to that particular column, and I do specify it by calling the name of the data frame. In brackets, I mention the column name, and then a .unique, the method called .unique, so which returns all the unique values that I have under this particular column called country. In case I want to return the number, then I just do a unique, something like that. Yeah, okay. So, so we decided to break the date. I think we've seen how the date appears. This is the date. It starts with month, then the date itself and the year. So we decided to split the date so that we can have a column for year, a column for month, something like that. And that is why I guess somewhere you saw import calendar, because it helps us maybe to convert the month name from figure, sorry, to convert the month from figure into month name. But this is how we do this is how we split the dates so that we are able to extract out the year and the month. And in case we had other elements such as hours, minutes, seconds, we can still be able to do that using this method called date time index. So what we do is that we just create new columns, and you can see we are using names that make sense. For example, what we want to store in this column is the year. So that is why we are referring to this new column as year. And now we are using the date time index on the data itself, the actual date that we have, .year. In other words, extract a year from this date and extract months from this date, something like that. So at the end of the day, when we run this, and then we run the data frame again by calling it, then we should be able to, sorry, it's taking a while. So we should be able to see these new columns, year and month, respectively. Right, so right here, I think you can see that we have year and then we have the month. So, so this can help us to do any kind of exploration that we would want to make at the end of the day, so that we are able to gather those insights or those hidden patterns within the data that we want to extract out from the data. So the first thing that we did here was maybe to, first of all, find out the countries that were most affected in terms of number of deaths. So what we do first here, we use the group by operator, and we do a grouping by country, whereby we're going to return a data frame that has the country itself, but on top of that, it also has these other two columns, confirmed and death. But these two columns are going to hold a summation of the values in there. In other words, for this case where we see Afghanistan right here, the value that we see here is a summation of the number of confirmed cases that we had in Afghanistan in our data set. Yeah, that is from 2020 to August 2021. And these are the number of, a summation of the number of deaths that we had, something like that. Yeah, then later on, we also create another data frame. And with this data frame, we bring in other operators, the logical operators. So here we want to return a data frame, or we want to create a data frame. But with this data frame, we want to return a data frame whereby the number of deaths that was registered in those specific countries is greater than, this is 10,000. Yeah, 10,000 cases in terms of death. And this is what we returned at the end of the day. So I think I can run this. Oh. Okay. Yeah. data has been changed again. Okay, let me just do this. It's yeah, that's exactly it. All right. Okay, this is a bit wide, but I guess the code keeps on changing. But so anyway, so with this, what we are trying to visualize is we are looking at, first of all, okay. So this was country, master affected, just a minute. I want to make sure I am visualizing what I want to visualize. This is recovered, I think. Recovered cases, so this is going to be recovered. Yeah. Okay, let me just look here. All right, I guess this could disregard. So, so here, this is a comparison between the death and the recovered cases that were registered. And we can see that, for example, for Brazil, okay, maybe let me just go back a little bit here in the code. So the bar plot is the one that has the death, information on the death, whereas the line plot is the one that has information on recovered. So we can see that Brazil, India, and US registered the highest number of death cases, but we can still see that much as Brazil registered the highest number of death cases, registered a high number, not the highest, a high number of death cases. Also in terms of recoveries, it registered a high number because we can see that on the line graph, the number of recovered cases are slightly higher than the number of death cases. Then we can see India registered the most or the highest number of recovered cases out of all these countries that we have in the data. Whereas for US, it registered the highest number of death cases, but the number of recovered cases were not that high. Yeah. So we can have this kind of visualization, or we can be able to pick out these insights using visualization. And then maybe we could go into South Africa, South Africa being our host, maybe to find out what really happened in South Africa. So since we were able to do a .unique on country, and we noticed that one of the countries in there was South Africa, then we can create such a filter using this logical operator of, return a country, whereby this country is, return the records, whereby in the country column, they are holding a value called South Africa. So this is what exactly this code is doing right here. And then the code below, what we did first was to do a break since we had information for 2020 and information for 2021. So right here, we did a sieve again or a filter again using here, but we can merge these two using the AND operator, whereby we can first of all specify the first condition for country on South Africa, and then the other condition would be for year on 2021, something like that. Then having done that, we went ahead to do a group by still, but now the group by we're doing it per month. And for 2021, I think we only had 8 months in there. So we had from January to August. And the data frame itself, what it's returning the number of confirmed cases and the number of death cases that we had. But this is a summation. So we can choose to change this to .mean or to .count, yeah? But all those methods are on the group by operator itself. Yeah, then from this, we sieved out the death, and we only remained with the number of confirmed cases that we have right there, so that we can maybe be able to know the composition, but to present this composition in terms of a pie chart, which we have right here down. So with this pie chart, we have a distribution, or we are representing these values that we have here in terms of percentages, right? What we see here. So we can see that the month that has the highest percentage is July, much as it seems like the whole of 2021, that is from January to August, the number of cases were really high. All the drops were not that high from one month into another month, because in month one we had 10.5, this incremented to 10.9, it went to 12.4, 12.3, something like that. And then maybe you might notice that part of the pie chart is exploding, and this is right here on this line of code. So the values that have set to 0.1 are the ones that are exploding, or the ones that are popping out. But in case I don't want them to pop out, I can just set it to 0, or I can just remove that. And then the number of decimal places, I've set them right here, 1.1F are these percentages. So this means that we are going to return a percentage, but to one decimal place. So that's why you can see 18.2, 8.6. Something like that. Yeah. Then still more into that, we can have a heat map. So this heat map, what we did, we came up with a pivot table whose index is the month and whose columns are the years. But the only values that we stored in the pivot table are the confirmed cases. So that the cases were really high in South Africa. That's why you see our values are growing exponentially. And in terms of visualization, we can have a heat map, something like this that you see here. So the color code that I've used is CMAP equals to blues, whereby the intensity of the color depends on the value itself. So you can see that for South Africa in 2020, the number of cases were not really that high from January to June. But now from July 2020 to August, you can see that the values are really accelerating, or they keep on growing. Something like that. So we can be able to make these observations still using visualizations. Then I think maybe the last part of this presentation would be the GeoPandas, or the geospatial bit of it. So we noticed when we called our data by name, we noticed that it had values, the latitude and longitude, and with these values we can be able to plot the data, because the best visualization for geospatial data is maps. Yeah, much as we can have line plots, etc., but the best visualization would be maps. So because I'm using Colab, and because by default Colab does not have GeoPandas, I have to make this installation of pip install GeoPandas. But in case you're using Anaconda, there are different ways in which you can have GeoPandas installed. So, okay, right here, I guess you can see these different packages. So one way would be to first of all consider installing these packages independently, the packages that GeoPandas depends on. So they include PyProj, they include Fiona, there is Shapely somewhere, there is GLAD somewhere, GLAD, yeah, something like that. Yeah, but I guess in the networking session, we can walk you through this, or you could choose to do the installation via pip install that is still in command line. But the best way would be to first install the packages and then you install GeoPandas. That is if at all you're running this on your local host. So if you're using Colab, you just do this and then it will fetch those different packages. Once you've finished with the installation, then you can import it right here in your working space, and still you can give it an alliance name. So here we gave it the common alliance name called GPD, in that every time we want to refer to it, we refer to it using that alliance name. So maybe let me just rerun this to be sure that I have GeoPandas. Yeah, okay. So I have it. That's why I have requirements already satisfied. So I can run this. And then the other import that we make, so from Shapely, from that package called Shapely, there is another package, Geometry, where we import point and polygon. So these are important because as we shall notice, for us to be able to visualize this data, we have to use shapefiles. So shapefiles, these are publicly available. You can have a shapefile for the world, for the continent, Africa, Europe, etc. You can have a shapefile for a particular country, for South Africa, Zambia, Uganda. So these are publicly available. These are publicly available. Yeah. So let me first skip this. I'll get back right into it. But so the idea is just like the way I uploaded the CSV file into this Colab working space. It's the same way I have to do for the shape files, because this is an external file that contains the shape of the map that you would want to use. So the shape that we intended to use was for Africa. And so that's why we imported the shape file. We read the shape file into this working space after dropping it right here into our files. Yeah, so once we've done that, let me run this again. So once we've done that, still a shapefile contains columns just like any other data frame. And these are the columns it contains. It has ID, it has code, it has country, it has geometry. But in case you want to have a look at the data, you can just call it by .head, I guess, so that you see what it means. So that you see the information. So this is the information, the ID, the codes are for the different countries. So the code for Algeria is ALG, for Angola it's ANG, something like that. And then here it has the geometry points, which are recorded as polygons. That is why we have to import that from from this place here. All right. Okay, so we could choose to just do a dot plot, maybe to see the shape in case we want, and that is exactly what we did here, to return the shape to return a visualization actually of this shape file. So it returns this shape for Africa, since we are using the Africa shape file. Now maybe the next thing for us to do is for us to merge the data with the shapefile, because the idea is that we want to plot the data on the shapefile. So for us to be able to plot the data on the shapefile, one way we could do it is we could use the dot merge. So, so for this case, our shapefile, we've called it Africa DF, and our data, we refer to it as data, remember, and this file that we are coming up with, we have named it merged set. In other words, it's the new file that we're coming up with. But now this merging, we don't want it to be done anyhow. So we want it to be dependent on the attributes that are common in either data frames. And those attributes include the country, yeah? So for the shape file, we noticed that country was captured in caps lock, for those of you who right here. So we noticed it was captured in caps lock, whereas for our data itself, somewhere we noticed that country was captured as with small letters, or just like what you see here. But in case you want to be sure, you can just do a dot columns so that you see. Yeah. So now country is like our key or our primary key that we are using to do a merge, okay? But since we have these names appearing in different ways, we can make that specification using the left on argument and the right on argument. So the left on argument is for the shapefile, and the right on argument is for the data itself, something like that. So now with this, once we do that merging, we can then call our new data frame, which is the merge set, and this is how it will appear. So it will start with Africa shapefile, or the attributes that are under Africa shapefile, and then it will go on with the attributes that are under data, okay? Because Africa shapefile was left and the data itself was right, but something like this. But the main idea was for us to make sure that the information right here is in sync with the information right there. That was the whole point right there. So once we have this merge set, then we can be able to do plotting. For example, we can come up with what we call a choropleth that maybe is going to help us to depict the different intensities, or to represent this information, but in terms of intensities. So here the colors, we specified that we want 10 colors, but these colors are going to come from reds. In other words, we are going to have red, but the intensity will differ depending on the value. So the column that we are plotting is confirmed, because remember, we already have confirmed right here, since we've merged the two data sets together. So we have confirmed in our merge set right there. So when we run that, then I guess it will return our map and this information. Wait for that. Okay, so it's taking a while. All right, so as it's processing, the next thing that we thought of doing is maybe DSA host countries. I guess we saw this somewhere on DSA page, that countries that have hosted DSA, maybe we would want to find how many cases did these countries have, yeah? So maybe it's the time we should think of a physical meetup, and then, yeah, so maybe it's the time we should think of a physical meetup. So we thought that maybe if we pick out countries that have hosted DSA, which I think I skipped right here, and I said I'll get back to it right here. So South Africa, which is hosting us right now, Kenya, which hosted us some time back, I think more than once. Same thing with Uganda, Tanzania, Ethiopia, Ghana, and Nigeria. Hope I've not left out any country, Maureen or Shira. But anyway, so we decided to do a filter with using the all operator, which is the pipe. So what this means is that we are going to return a record. We're going to return, what this means, it means that we're going to return data whereby the countries, it's either Nigeria or Ghana or Ethiopia or Tanzania or Kenya or Uganda or South Africa, something like that. Yeah, and so I thought that maybe it's important for us to do a visualization on that to see how those countries were affected by the pandemic. But maybe just to go back to this, so this is what comes out from this plot. So we can see South Africa was really hit, and this is a summation for both years. But like Dr. Dina, Dr. Deep, and the other speakers have indicated, you can be able to come up with a couple of questions that you think are important for your analysis, because the whole idea is that you have data, but you want to extract, you want to get information from this data. So much as here we are doing a summation, but we could choose to concentrate on 1 year, 2020, 2021, something that we've depicted in the heat map. Yeah, so something like this. So you can see South Africa here was hit, and these other two countries are in North Africa. So if we choose to sieve out, the countries that have hosted DSA, including the current host, it means that now we are not going to consider data, but we are going to consider that new data frame that is holding information on these specific countries, and all the other things are the same. So we still do a dot merge, but we are only changing the name here. And then maybe we also decided to change from reds to blues so that we can have a different visualization. So as that runs, I guess this is the take-home exercise that we thought of. Okay, so this is what we have. So you can see that now the shape is a bit different, though maybe because most of us or all of us are familiar with the shape of Africa, maybe we can still see the shape of Africa from this, but we can see it's a bit different because we've specified that we only wanted information on Uganda, on Tanzania, on Kenya, on South Africa, on Ghana, on Ethiopia, something like that. Yeah. And right this side, we have the legend for these different color intensities that we have. So that is the end of the tutorial. And the take-home exercise, what we thought of is that maybe you could use this data, which we have shared or we are going to share, or you could use any other data that is available on the links right here, the World Bank link, and think of generating time series data on case incidents, recovery fatalities of 5 countries, any 5 countries of your choice. Then you could maybe make a comparison on how COVID impacted the 5 countries over or during the different waves, yeah? Because I guess we had information like this is the first wave, this is the second wave. So you could be able to use that external information to guide you on how to run your visualizations. And then maybe lastly, you can prepare a 1-paragraph write-up to summarize your findings and provide some explanations from what you've observed in the data. For example, did cases start coming down from a specific time, such as January? And if that is the case, could it be because of the vaccinations? Or maybe if there was a peak, could it be because of the mega spreader events, things like that? Yeah, so that is what we thought of in terms of take-home exercise. And thank you very much for listening to us. Back to you, Shira.
Thank you so much, Claire and Stuart. That was great, and thank you for leading on the practical session. Just a quick note that we've looked at the data from absolute numbers. So one of the reasons why we look at external other data sets is also to see what happens in relative kind of numbers. So it's not just the absolute numbers, because the population of different countries are different. So you could think of these kind of external data sets providing that complementary view of cases per 100,000 the population or something like that. So that was really well done, Hewitt and Claire. Thank you so much. And over to you, Shira.
Yeah, I was saying over to Hannah and Eli and Maureen.
Thank you, Shira. We still had about, what, 3 minutes? So I don't know if there's anyone who has a question. Again, we will have the facilitators available in the next 30 minutes in different breakout rooms for you to engage more. Okay, so if there is none, I will ask if Amy is around. Amy, are you on the call? Oh, perfect, you're on the call. Okay, so thank you. Let's first give a round of applause, of course, to the data visualization team for the great job. So yeah, share your emojis of things and everything. That was a great presentation and tutorial at the same time. Again, let's engage with them more where we have any issues with, let's say, the assignment that they have given us. Let's engage with them later on in the networking session. So right now, I am going to invite Amy. Amy is from Zindi, and she's the one who's going to tell us more about how we can go about the hackathon and start coming up with solutions for the challenge that we have. So now is when you're going to be able to ask any questions that you have about how to go about, you know, the Zindi platform, or even how to come up with great solutions and make sure you win the prize for the hackathon. So Amy, I don't know if you have slides to share or you're just going to talk to us through it. But yeah, the floor is yours. You're welcome.
Sure, I've just started sharing my screen, and I'm going to turn on my video just for 30 seconds to say hello. This is Amy. I'm the competitions lead at Zindi, so I'll be following the discussions today, this week. So if you have any questions, I'll be the one answering them. So 30 seconds, what is Zindi? Zindi is a community of data scientists solving Africa's toughest challenges. We have this lovely quote from Lawrence, who works with Microsoft Africa, and I really strongly believe in this. The only way we're going to fix Africa's problems is with African solutions, and this is where you come in as Africans. A bit about Zindi: we have over 30,000 data scientists, and they're from 48 countries in Africa. We have 6,000 Twitter followers. We have 250,000 page views per week. I think this number has gone up since I created the slides. And we're very proud that 25% of our users are female. I think the normal number is 15% in tech. So we really like to see that it's 25% female. So we've launched 150 competitions and hackathons. You are part of that number. We have up to 2,000 data scientists competing in hackathons. And we've given away nearly $300,000 in cash prizes. We've also hosted the largest Pan-African virtual hackathon, where we've had over 1,000 students from 126 universities. We run this in March of each year, so please make sure to reach out to your lecturers to make sure that Umoja Hack Africa is at your university in March. So a bit about the competition. I'll also share the link. It's can you estimate the percentage of households per ward that are female headed? A ward is a voting district. So we have South Africa is split up into 9 provinces or 9 states. Those states are and provinces are then subdivided into municipalities, and those municipalities are divided into wards, which are just smaller enumeration areas. So can you predict percentage of households that are female headed and earn less than 19,000 per year? This data was collected in 2011 or 2011. So it's a bit outdated, but I don't think that number has changed much in South Africa, which is really disheartening. The reason we have this challenge is it's really expensive to do surveys each year and censuses. And especially since we only do censuses every 10 years, there's huge gaps in our data. So can we use variables that the government should be collecting each year, such as nightlights? Nightlights we can get from Google Earth Engine, access to running water, health and sanitation should have that for each house's. Language, no idea what I'll say if it's in there. Language, we should have that from ID documents and school registration. So can we fill in gaps in censuses with other data that should be collected? I'm going to come back to this slide at the end, but the secret code for this hackathon is DSA 2021 H for hackathon. So that's DSA 2021 H. You should have received this in an email as well. That was a very quick introduction. We have just started a new visual design on Zindi, so it's all very exciting. If you have not created a Zindi account, please do. You can just head over to this top right-hand corner where you can enroll. You're then going to click compete. You're going to scroll down to near the bottom of the page where you need to select if it's password protected. Here's your password or your secret code. And so here's the password protected. Scroll up to the top and here's your hackathon. And you have $600 up for grabs, which is really exciting. So we have a quick description of the challenge. We go through the rules. We then have the evaluation metric, which is the root mean squared error, or RMSE. I think during this week you will discover more about machine learning and what the different error metrics are. Here we have the prizes, and this closes at 2 o'clock on Friday. So I'll see you on Friday to announce the winners. Wow, I'm talking really fast and I've only been going for 5 minutes, so I'm going to slow right down. On the data section, it describes a bit about the data. So yeah, this is from 2011. We are looking at about 3,000 models in your training, 3,000 wards in your training, and about 1,000 wards in your test. So it's quite interesting that these wards are split across the country. Some of the wards for the test set are in the Western Cape, which is a province, and the Western Cape is one province that is ruled by a different party. So it just could be interesting to look into that to see if different wards in different states or different provinces are different. So these are your files that are available for download. You have your training file. So in machine learning, which you'll learn along, is we take the data and we split it into a train and a test set. Train is what you train your model on, and then test, you pass through the test data, and that's what you predict. We then have a sample submission. So for each row in the test, you need to make a prediction, and then you submit your prediction in the submission file. Sounds super confusing. We'll get through it. We then have the variable definitions file. As this was pulled from a census, the column names are super confusing. And when I go through the notebook, you will see me scrolling up and down, trying to decipher what the variable definitions are. And then finally, we have a starter notebook. The starter notebook shows you how to read in the data, do some interesting visualizations, create a machine learning model, and then make a submission. If you are comfortable doing machine learning by yourself, if you feel comfortable doing something else, and we really encourage you to pursue that, this is no way a textbook answer, and we really encourage you to build on that. So we do have a latitude and longitude. This is the center point of each ward. And then the that's just the code for the ward. You cannot use any GIS filters or features or software programming. But it's just there interesting for interest's sake. So over here, as the competition has now started, you can download the files. I don't know if you've been introduced to Colab yet, but I'm just going to show you how Colab works. So you're going to type in colab.research.google. Once you've downloaded the files from here, you can upload your starter notebook. Then we're just going to, and then you click connect over here, and you can upload your files. The starter notebook's a really nice short run through. It explains each section in detail. So over here, we're importing our data processing scripts such as pandas, numpy. We're importing a plotting library, matplotlib. We should run all of this. So here we're reading in the train set. As you can see, we have each ward. We have the total number of households. I wish I could explain to you why there are decimal points, but this is pulled straight from the census. So this could be an extrapolation of the houses that they did interview. So for Ward 1, there's 167 for households. There's nearly 6,000 individuals, and 16% of these households are female and earn under 20,000 Rand per year. That's less than 2,000 Rand per month. And here we have our, I think there's 60 features or 60 columns that have very confusing names. DW stands for dwelling, and we're going to have our different dwelling types. PSA, we'll get to, do they have a TV? Do they have a car? What language do they speak? Etc. Our target is, just to remind you, percentage of female-headed households under 20,000 Rand per year. Here we read in the variable description file. Here we have language number 4 is percentage that have listed their language as isiZulu, Sepedi, Sesotho. Percentage population group, Black African, Colored, Indian or Asian. Here we have percentage of piped water inside the institution by the yard, within 200 meters dwelling, 200 meters from the house, etc. Here we have the latitude and longitude. Remember, this is the center point of each ward. Missed how to access the competition. So I'm going to quickly go back. It's a really nice, simple name. It's Cindy.Africa. I'm going to post that in the chat. We're then going to go to compete. Scroll down to show the password. Scroll back up, and you're going to be at the top of the list. And the password or secret code is DSA 2021 hackathon. Okay, back to our notebook. Everyone, I am looking at the chat periodically, so if you have any questions, please interrupt me there or just raise your hand on Zoom. Here we have our quick EDA. It's taken me a while to understand this EDA because the target is percentage of households that are female-headed under 20,000. So about 10%, I don't know, I'm going to expand that graph. It's such a brain teaser trying to go through these graphs, and I really encourage you to spend time. So this is our correlation between the variables. So PSA 0 seems to be our strongest correlation, and then CAR 0.1. So if we go back to here, our PSA, I think it's access to running water. Oh, PSA is percentage listed present school attendance. So if students attend school or not, that's a good indicator. And the next one is if they have a car or not. Interesting. Then we have our negative correlation, which is the exact same. Also very similar. If you think of we'll get into correlation matrices, I'm sure. As you can see, our population with piped water, there seems to be a negative correlation here. So people with no piped water, there's a higher percentage of them not having or being a female-headed household under 20,000. Where if you have piped water, there's fewer households that are in the target group. A couple of graphs have been plotted. I recommend that you go through each of the variables, try and find some interesting variables. Something that happens in a Zindi competition is everyone becomes so fixated on creating the best model, just doing a million iterations, where I think there's a lot more value in digging into the data, doing EDA, finding interesting results. In the long run, that is what's going to make you a better data scientist and make you more attractive to a company, that you understand what the data is, instead of, I can run 1 million models in 5 minutes. So I'm going to scroll over a couple more EDAs, and I'm going to get to our modeling part. So some of our features are categorical, so we are going to need to change those. We are specifying what our Y column is, so that's our target variable. We have very nicely called our target variable target for you. We're going to do a simple linear regression model. Python has amazing machine learning libraries. I really recommend that you play around, see what different types you can do. There's something called ensembling, where you can find different models and join them together to see what interesting result that brings, and if you can increase your accuracy or reduce your RMSE, as that is the evaluation metric. So we're going to use a linear regression model. So we're importing it from the Python library. We're creating our learner. And now we're just going to fit some of the data. And we get an R-squared score of -0.87. This is not your RMSE score, this is just your R-squared score. So for an RMSE, we get 29.72, which is quite bad. So let's see what happens. If we plot on our test set what our predicted and true values are, we can see that we fit really well for most of our values. However, there's a few outliers. What on earth is going on there? So let's try a different model. Let's try a random forest regressor. This is probably the best go-to. It's your RF model. And now we get a score of 4. Remember, we had an RMSE score of 29. Now we've got an RMSE score of 4. And if we plot that, we get a lot better straight line, which means we've missed out on all of those outliers at the bottom. If we look at our feature importance, I don't even know if zooming in is going to help. No, it's not. If you save this image, you'll be able to see which features are the most important. Couple more. I really recommend that you look into cross-validation. What is cross-validation? How does that make you a better data scientist? Scrolling over here really fast. You can do some feature engineering or some model tuning. So it's quite funny. A lot of people think that you are a data scientist because you can read in the data, put it into an RF, a random forest, generate an output, and you're good to go. There's actually a lot of creativity that happens in the feature engineering and in the model tuning. So model tuning is when you go onto Python's, what do you call that? Like that data sheet, the library information, and you'll find all those parameters. You can tweak and change those parameters to get you a better model. Okay, here we have our submission. So bear with me, I'm going to scroll all the way to the top and hope that we read in our test set. We did not. Scrolling all the way down to the bottom. Okay, here we read in our sample submission, which is for Ward 1, I've randomly made up that number, 21. For Ward 2, randomly made up that number, 65. Ward 4, I've left blank, and you need to fill that in. And you need to override these top 3 values because these are made up values. Here we read in our test set. Our test set looks very similar to our train, except that it's missing the target value. You need to include the target value. Where you include the target value is you apply your random forest regressive model. And here we have our target. You then create your starter notebook, which is what we've done. And here it is. Very confusing. I'll be on the discussion board if you have questions. I've now just downloaded the starter notebook. This is how you make a submission. So you go to the competition, you join, you put in your secret code. And you can make a submission. So I get a score of 3.9. If we look at my notebook, I got, when I ran it locally, I got a score of 4.9, I think, if we remember correctly. A 4.1. But this was just because we are testing it against our train set. On Zindi, we keep the test values on our back end. And so that's why we have a score of 3.9. I absolutely love doing tutorials because it means for a brief second I'm on the top of the leaderboard, and this is your score to beat for this challenge. If you run through the starter notebook exactly as it is, you will arrive at the same score as me. But yes, through model tuning and feature engineering, you will definitely beat this score. At the end of the competition, we will announce the winners on Friday, so I'll see you then. If you have any questions, please either type them here or unmute yourself. That was a really quick introduction, and I do speak very fast. But all the information is in the Slack and the Zoom channel here. All you really need to know is about the data. If you scroll down to the bottom, you'll find the starter notebook and your files. If you walk through the starter notebook at your own pace, you'll get a file that you can submit over here, and you'll land up on the leaderboard. On Friday, we will announce the winners. The top 3 winners will receive $300, $200, and $100, which is really amazing.
Hello, my internet has dropped. I don't know. Amy, are you done?
I am done.
Oh, okay. I'm so sorry, my internet dropped, so I just joined, I think, when you were finishing. All right, so like Amy said, that was a bit of, complicated. Some of the things were hard, but that's why we have the next session where you get to actually really, if you have any particular questions, interact and engage with Amy. I don't know if you want to shoot some of the questions right now. Hannah, how much time do we still have before we break into other sessions?
It's 5 minutes, ma'am.
Oh, thank you. Okay, so and do we have any questions in the chat? Because my chat now is clear, having left and rejoined.
There aren't any questions so far.
Okay, all right then. So I will request Shira, or I don't know if it's going to be Gabriel, to help with creating the breakout sessions. We will leave the main one open for the hackathon questions. Please engage Amy while she's still available to have any clarifications with how to participate if anything was not clear. And then we will have another breakout session in which we will have Dina and the data visualization team. I hope you're still around for just a few more minutes in case participants have questions that they would like to ask you. And then we will have another room. Did I call it session? I meant room. They're going to be breakout rooms. And then we'll have another room for Ernest. And then you can, keep joining in different rooms to go and make inquiries depending on where you need more help with the work. So Shira, how do we go about that already? Have you started creating the breakout rooms?
Okay, so Gabriel, I think we'll set up, Gabriel is going to set up a data visualization room, computer vision room, and then I can't remember the session in the beginning, introduction to Python, was it? Yeah, I've forgotten the title. But all the sessions, and then as you said, so there'll be breakout rooms. I believe, Gabriel, you're setting those up. Yes? Gabriel?
I'm about to set them up.
Okay,
so
cool.
They'll be set up.
Thank you.
Right. And in the meantime, sorry to jump in, I think it's good to just remember our sponsors. So JEDIA, who is Gender Justice, Digital Innovation in Africa. So we are really interested going with the theme of women and data in Africa. So it's important for all of us to remember that. We're highlighting the important work done by women in this field. And for tomorrow's sessions, I think you've been sent some important links to get data. So prepare. There's a lot of work to be done, participating in the hackathon and also setting up for tomorrow. With the follow the information on the repos and our YouTube channel. You can subscribe and also share it with friends who may not have registered. That is something you can freely share. And our Twitter page, please follow that as well. I think that is all. I'm waiting for Gabriel to set these rooms up.
All right, thank you for that, Shira. And I just wanted to also mention that you should have received emails about some of the things that we need to set up for tomorrow's sessions to be ready for the sessions. I sent that on email. Please go ahead and have your environments ready for tomorrow's session. And maybe just thinking out loud here, maybe we could stop the live stream. We still want to continue the live stream. Shira, what do you think?
You're right. There's no need for it now. We can stop it.
Okay, cool. Thanks. And I just want to say
just
thank
give us
you
a minute as we set things up.
Yes. Thank you for that. As I'm just going to say thank you to our facilitators who have agreed to stay a bit longer for the engagement, for the networking session. I know it's probably lunchtime or even past lunchtime, but if you want to engage with them, you do not know how long they are going to stay. So I would suggest that we engage them now, and then once you've finished that, you can go ahead to